This. And it says I'm live. Hopefully I am. Good evening, everybody. Good night, or whatever time zone it is. I just read on the chat. Some people, it is morning, very early morning, Nicholas. I hope you're not specifically up early for me and just happen to have an early day. So yeah, welcome everybody. We're gonna have a look-see what's in store for today. I've been wanting to do another Godot demo for the Godot demo project site. So obviously, the character-centric and origin-centric demos are already on there. I made those a little while ago, and I always forget the proper link for this, but they are based on the room scale documentation that I wrote a while ago. So this all talks about the fun situation that you can get in if you don't think through the impact of room scale tracking that we have in VR. So the fact that we have an origin point, which in Godot is represented by the XR origin 3D node, and that as the player walks through the room, that obviously we are moving our tracking point through the room. A lot of people making the mistake that the XR origin point is also the location of the player, which, as you can see very clearly from this picture, is not the case. So we look in our documentation about a few of the mistakes that people as a result make. So for instance, the walking forward with your joystick, thinking that you're going to move over the bridge, but because you have made the mistake of putting your character at the origin point and therefore your capsule at the origin point, you just walk off the cliff instead of over the bridge. The other example being when you rotate the player, instead of rotating the player around the actual location that the player is at, you are rotating around the origin point, so you're rotating around the center of your play space, and you get a funky situation like that. And then obviously the last situation is what happens when you physically walk through a wall that you're not supposed to walk through. So in the documentation here, we are describing two different setups. The first is the origin-centric solution that we have to give it the name. This is the approach that we have been using for quite some time. At least I have been using for quite some time. And also that is the approach that is used in XR tools. And basically it means that you look at where your camera is, you work back from where your camera is, where your character is supposed to be, and you move your capsule around that way. So we're starting here with our normal setup, XR origin camera, and then we have a neck helper location that will help us locate the position of the body. But we work back from that. I don't have actually got pictures for that here, but we work back from that. And we then actually move the capture shape. The capture shape is actually a character body with a capsule. Oh yeah, that is in here. So we have our character body as a child of XR origin with the shape, and we're kind of following the character body, or following the actual player location with this character body. So the XR origin 3D, if the player isn't moving with that joystick, the origin stays in place. The camera moves around as the player physically moves throughout the room, and the character body as a result follows it. Then when the player actually wants to move based on joystick input, we're actually moving the XR origin point through space, but we're applying some funky math to make sure that movement is working. So we have some logic here that does the moving of the character body to move it to wherever the camera is. So this is the whole implementation of what I just mentioned. You figure out, okay, where's the player supposed to be, and you're moving the character body to that location. And then step 2 is where we introduce rotation. So here we got some funky math that rotates the player around the location of the player, not around the origin point, even though it is the origin point that we actually end up moving. And then I believe that the last step is to move the player forward or backwards or left or right, depending on joystick input. Same deal. We are moving the XR origin point here accordingly. And there's a little bit more sauce in here that is if you try and walk through a wall, obviously with the joystick you just get stopped. But if you physically walk through a wall, which is actually handled over here, then we actually don't move the player body through the wall. The player body stays behind, and you get a nice out of body experience. And you can deal with that depending on how we exit here. Now, the second option that is described here is the character body-centric solution, and that is actually a newer setup that we started using, and that we do plan to move extra tools to at some point in time. And here we have a much more traditional setup where the character body is the root of our setup. Obviously has a collision shape, and then we have our origin 3D with our camera and with our neck. And the idea is that the character body is actually always going to be where the player is. And in this case, what we're doing is a little bit of magic on the physical move. So, so you see that the physical move logic is a little bit more complex. Let me get a little bit of drink. But we're going to try, and still, you know, when let's say that the player takes a step forward, so the camera moves a step forward, the camera is now over here. We are then going to attempt to move the character body from its current location to the new location where the player has physically moved to. And provided that is fully capable, what we're now going to do, because now, of course, the camera has moved forward because the player has stepped forward, and it has moved forward again because we've moved the character body forward, we're now going to move the XR origin point backwards by the amount that we have moved the player, which means that the camera again ends up in the position where we started, but now the character body is actually at the location of the player. Excuse me. Hey Simon, how are you going? Nice of you to join today. I'm just giving a really quick run through of the room scale documentation. We did cover some of this last week, but I think it's always good to have a reminder here. Anyway, so the nice thing about this solution is that basically this is it. We have now moved our collision body, our character body, to the location that the player is actually standing. And we've moved the extra origin point in the opposite direction to make sure that the camera ends up back where we started. So as the player physically moves throughout the room, the character body moves throughout the virtual world, and the extra origin is just compensating to make sure that the player and the character body are always in the same spot. And that now means that our character body, as far as virtual movement is concerned, so movement done with your joystick, is now done like any other application. So we're basically doing the same thing as the other script. We are in step 2, we are introducing rotational input, and as you can see, that's now a one-liner. We're just rotating around the y-axis. And in step 3, we are introducing our movement code. But lo and behold, when you look at this code, that is actually, and I can actually probably show that if I quickly go into, let's just open that just for now. It doesn't really matter. That's the wrong one of the two. But I just wanted to show as an example. So let's just create a new scene here. Do I want to do that? Actually, let's create a new project, shall we? Because I don't really want to change that one, and we're just going to create the project that we want to work on today. So that's going to be projects, browse, and then demo project XR, select, and we're going to call this a good question. What am I going to give this as a name? What is definitely going to be OpenXR. What am I call it? Vehicle movements. That is a really good question. How do we name this? Yeah, let's just call it vehicle movements. Movements. And we're gonna go create a folder for that. And now I can actually. It used to be that when you gave this a name, it would nicely get you a snake case name for you here. But nowadays, it just actually keeps the case and keeps the spaces, which I hate well, hate is a terrible word. Which I dislike for path names. I don't like spaces in my path names. It is always a pain in the butt to deal with spaces in path names. But anyway, so here we have a new scene. For now, we'll just create our main scene. Boom. And I just wanted to do this so that I can save it, even though everything that we're creating right now is not going to be very interesting. So let's go and create a character. Obviously, this is not for this demo. I just wanted to show that for the centric movement demo, or the character body centric one. So I've got my character body here now, and if I say I'm going to create a script on that, and I'm going to use the basic movement template, you will actually see that, except for that, for whatever reason that I never understand, where are you? Yeah. That we're using the local transform here for movement and not the global transform. I think that is actually a bug in the script, but that's me. But when you look at this code here, oh, there's a jump in there, so forget about the jump. It's here. Oh, there is no rotation in this. There's purely movement in this. That's, I guess, because the rotation normally in the normal game is handled by mouse. But my point is, this script is exactly the same as the script over here, except then, of course, you know, I changed this to make sure that the global transform is used, which tends to be important when your character body is not a root node, but is actually a child node or something, and that child node is moved somewhere into the world. You can get some weird movements if you use the local transform there. Anyway, the point here is that other than this big script over here that handles, you know, like I said before, that handles the movement of the character body to make sure that it moves to the location that the player is at physically, and then moves the XR origin in in the opposite direction to counter that and make sure that our camera actually ends up where it belongs. Once that is done, the character body, as far as virtual movement is concerned, you know, movement controlled by the game instead of movement controlled physically by the player, is just normal code that you would also apply for a normal character. So this is a approach that is far more suitable. Well, it's easier to work with, I think. And I, by the way, I can't take credit for this. Saracen, if I am not mistaken, was the one who originally suggested this many years ago, and took some time to finally convince me that this was actually a good idea. And when the penny dropped, I went like, yeah, this is best thing since sliced bread. And I ended up implementing this. But I think this is a much more natural approach, but also because the character body is now the root, and you can build your player rig on top of this, and make sure that you have a body, a avatar, or anything like that. It becomes much easier to adapt a game that is both a VR game, but can also be like a first player game just on desktop, or a third person game on desktop by just replacing this part. Instead of using our XR origin, you just put a normal camera somewhere, and you you can reuse much of the player script for movement, and maybe add a little bit of, you could potentially have a mouse control, obviously the up, down, left, right, look for your camera, that sort of thing. So this is a pretty decent setup. And then I had obviously written this, and then people sort of asked, where's the example source code? So I created the two demos that are on the Godot demo project, and also for that matter, for those people who are not aware, obviously that is all hosted on the Godot engine GitHub. So there's a folder XR here, and there we find our two movement scripts. Now, there's a third option that is often overlooked. No, it's actually not overlooked, because I showed that working in my vehicle tutorial series, but one that we don't actually have any discussion anywhere on how to make that work, and how to deal with that. And that is a situation where you're not playing a character that is freely moving through the world, but your character that's sitting in the pilot seat of a plane, or is sitting behind the steering wheel of a car, or any sort of scenario like that. Ooh. Separate Grabble VR calls from press E to hold. Yeah, exactly, Simon. That is a really great point. So here I'm obviously in my remarks around the character-centric approach. As far as the character moving through the world, it is much easier with that approach to use the same code both for the VR game and for the desktop game. It's just that in the VR version, you need to do a little bit more to deal with the physical movement of the player, and other sort of things. But at the same time, obviously the whole interaction, so the rest of the gameplay. Let's say that you're making a shooter game, for instance. The weapon handling that you do with your hands in VR is very different from the weapon handling that you do when you're playing with a gamepad, or when you're playing on a normal monitor. So obviously there are more changes that you need to do, but it is easier to swap things out. Although, as easy as, or I wouldn't say as easy as this makes it, but as much as this at least solves that particular situation, there is a fundamental difference between the two mediums, and this is really well contextualized when we are looking between the different sort of games that you could make. So like the example that I just made, I'm going to make a first-person shooter game. Let's say that and I still actually need to talk to the guy who's making Road to Tarkov, but let's say that I want to make a VR version of Road to Tarkov. Then obviously this approach would be fairly easy to retrofit into Road of Tarkov. Now I need to add a bit of extra sauce, that the gun handling in Road to Tarkov needs to have a VR-ified version of that, but the game itself will not fundamentally change. And on one side, that leaves you to wonder, now, is VR then a gimmick in that situation? And on the other side, you're sort of going like, why would I bother? And to some extent, for a lot of games, when you are talking about games that are made for desktop and that are then enabled for VR, that's a valid question to ask. Why would I spend this much extra money on a VR headset to play a game that I can already play on the desktop in VR? And the short answer of that is the immersion that comes with VR is worth it. It depends a bit on the game. It depends a bit on you, if you get motion sticks in that sort of games. But the funny thing is that the immersion side, is makes that worth it. However, the problem that I have with advising that and making people like, oh, I can now make my games both for desktop and VR, and therefore I can, I have this big desktop market that I can still sell my game to, is when you look at what makes a VR game special or unique from a desktop game, is when you go a step further than simply making a desktop game playable in VR. And that is when you are actually making use of the fact that you are able to move through a location, and the fact that you are able to physically look at things closely, or that you can grab things, or that you can interact with your hands. That's obviously what VR makes VR special. And that opens up a whole bunch of gameplay mechanisms that you can then no longer repeat um, on desktop. And it's really interesting because, for instance, Half-Life for me is a really good example. You can take Half-Life 2 and you can add a VR mod and you create a VR version of that game, and provided that you don't get motion sickness by movement, because that is a downside for first person type games that are now reproduced in VR. You now get a game that is just as cool as the original, but where the immersion adds a factor. But the flip side is more interesting. Now you take Half-Life Alyx, and you take a game that went a step further, that hasn't just moved that mechanism from desktop into VR, but then went a step further, that you can use your hands to open cupboards and open doors, that you can use your hand to look around corners, that there's all these sort of things that you can do. You can pick things up and throw them at your enemies. There's all sorts of puzzles, physical puzzles, that you need to now interact with your hands and do. Those sort of experiences only shine in VR. When you then go back into desktop, suddenly those approaches start failing. So yes, you can make Half-Life 2 and then port it to VR and have a game that has something extra to offer, or you can make a game like Half-Life Alyx, which is purpose built for VR, that you can't really port back to non-VR without losing what makes that game special. And I think that is for anybody who wants to get into VR and who wants to get into making VR games. That is the question that you need to ask yourself: is what's special about VR? What gameplay elements can I add to the game that I want to make that are not reproducible, or do not make the same sort of sense in desktop? And the interesting thing that I find is there are a lots of gradients, or you know this is not a black and white situation. It's not these games are fun in desktop, these games are fun in VR. There are games like this, right? You name Beat Saber is a very good example. Beat Saber is incredibly fun because you're physically slicing blocks with lightsabers. You can only do that in VR. That mechanism is VR only. There is no way that you can reproduce that game on desktop without it no longer being fun to play. While on the other end of the spectrum, on this side, is indeed I have Half-Life 2, or I have Halo, or whatever game, name your favorite FPS game, and you're converting that to VR, and basically you end up with a game that is basically the same as the desktop game. And depending on how good a job you do, it might actually be more fun in VR, but it can just as well be less fun in VR. It all depends on how good you port a game like that. And a good example for me there is when you, for instance, look at Skyrim. I love Skyrim VR. It's beautiful. It is impressive. And then I go back and play it on desktop. And the reason simply is that once the wow factor is off, like I can look around and I can see the moon and I can see and yeah, I can slash my sword at an enemy because it's still basically Skyrim and the mechanics are still basically Skyrim. The illusion breaks very quickly. And I don't know if by now, because I haven't played Skyrim VR for a long time, and I originally played it on the PlayStation 4, so I don't know if things have gotten a lot better, and even on a PC port where you have proper controllers instead of the Sony Move controllers, whether that game has improved a lot in that experience. But my point there being that those games, whether you're playing them on desktop or whether you're playing them on VR, doesn't necessarily have much difference. But there are other games on that scale. And one that is relevant for what we're going to do today is a game, games like Gran Turismo or Assetto Corsa or any driving game or any simulator game, Flight Simulator falls under this character as well, where at face value, it's like, what's different? Let's say I've got it's off camera here, but I have a proper racing sim set up here because my son loves sim racing. So, with a motor, steering wheel, and everything. And he plays Gran Turismo and Assetto Corsa and all that sort of stuff. Forza, you name it. When you play those games in VR, you're playing the exact same game. There's no difference. Whether you are playing it on the PC, well, there's no technical gameplay difference. Because you're still, moving the steering wheel around. And if you have, and which I don't, by the way, if you have a proper racing sim setup with, the big screen in front and the two side screens, VR doesn't offer anything. If you have the single screen in front of you, then VR does offer something, because the thing that you're missing when you're playing simulators, whether it's, and for me, it's like I was playing, actually both my son and I play Elite Dangerous, and we play that exclusively in VR for this reason, because when you're just looking at your screen, you're just looking forward, you have this relatively small field of view, and while that is often enough, you look at a racing game, you're mostly looking forward until you get yourself at a corner. And at that point in time, the ability to move your head and look that way, or look that way, or look beside you, which you cannot do if you just have a monitor right in front of you. That is the difference between night and day. And that can be the difference between, especially in multiplayer, between winning a game or losing a game. Of course, except, of course, if you have the 3 monitors around, because then that potentially is still better than VR, depending on the quality of your setup. And the fact that the setup like that, you're talking about it, multiple thousands of dollars, if not over $10,000 of investment for a proper sim rig, which is a little bit more expensive than your average VR headset. The advantage of not wearing a headset is that you can see your hands, you can see your steering wheel, you can see the buttons, right? Once you put your headset on, that's gone. You have to do that stuff on field. Now, usually that doesn't matter because I'm just holding the steering wheel. And especially, a well-designed game where all the buttons are in reach on your steering wheel. So as long as you know what your steering wheel is, you can manipulate the buttons, no problem whatsoever. But the moment that you go a step further and you do need to be able to use your keyboard or your mouse or something to navigate through the game when you're not racing or not flying, or not in your spaceship, then all of a sudden, not being in VR, but having a big screen set up is better. I do have to say one thing, though, and it's, I haven't played enough sim games to know whether Elite Dangerous is unique here. But the way that Elite Dangerous solve the I'm playing with a gamepad, one of these guys, right? This is my, it's probably too dark to see, but my PlayStation 4 gamepad that I use on PC. The way they have used that and make sure that you can play the whole of Elite Dangerous with just that, and you know, just having, you know, the 4 buttons here and the D-pad, and you're still using the joysticks to fly the plane. Well, you got triggers. You have very limited buttons compared to a game that's actually designed to use almost your whole keyboard for keyboard shortcuts and how to control your spacecraft, and especially with, you know, selecting weapons and managing power, communicating with other players or with NPCs, etc., etc. The way they have solved that, I don't know if any of you have ever played Elite Dangerous. Just for that, if you have a VR headset, you know, a PC VR headset, spend because I think Elite Dangerous, you know, it's a pretty old game by now, so I think it's often on sale. Even if you just play it for an hour and then put it away, purely for the experience, you know, play it with a gamepad, play it in VR, just for the experience of how they did the UI. It's, for me, it's textbook. Elite Dangerous, the user interface, the VR user interface, the way that it is, you know, we're talking about I think almost a 7-year-old game, if not older, or probably the game is older, but the VR support was there since the early DK2 days, if I'm not mistaken, or at least since the early Rift days. They were already using Gaze UI. You look to your left, there's a menu there. Now you're interacting with that menu. You look to your right, there's a menu there. You're interacting with that menu. You look straight forward, buttons now become that. There's hold a button, you know, hold a button on your D-pad, and all of a sudden the circle menu comes up and says, hey, combine that with these. And in the beginning, you're a bit sluggish. The more you learn where everything is, the faster you get. And it was way ahead of this. It's time, if you ask me. I think if they go one step further, let me clean my glasses for a second. If they go one step further and they, instead of, you know, needing to move my head, they actually use eye gaze. Ooh, ideal. And they were doing that years before anybody else came up with it. So I'm impressed. And again, like I said, you know, if you get a chance to pick up the game, if it's only to experience the UI system, you know, just play through the tutorial to get the hang of how it works, and then never play the game again, just for that. I think you learn so much about UI and VR and how to do UI and VR right. Absolutely can agree with that, or can recommend that. Let me catch up on on chat. 1 real world. We can be in Mickey Mouse world that our brain will simply accept. Yeah. Yeah. Let's put a pin in spatial audio. I want to talk some more about that in a second once we've caught up with everything. But indeed, you know, it's the immersion part that really makes VR special, and it's the way you interact with the world. Indeed, it doesn't have to be a real world. It's just the fact of that it's a natural interaction that we're after. VR scale game. Your 21 Ghost VR. Oh yeah, that's pretty cool. Malcolm worked on. He made a demo that's downloadable from his GitHub, called the Alice Maze, where you know, the inspiration is obviously Alice in Wonderland, where you constantly scale from being a giant to a mouse-sized character, a giant so you can reach up on things, and then become a mouse so that you can go through a small door opening, or yeah, really, you know, for a little demo, really cool execution of how you can, you know, how you don't have to be a lot human size to enjoy your VR. You have to be being a giant, and VR allowing you to be a giant that actually feel like a giant and actually see the world shrink, or the other way around, to be a mouse and see suddenly the world being immensely huge from your perspective. That's a cool part of VR. So yeah. Let's see. So 6 degrees of crispy bacon. Yeah, I've got Elite Dangerous pretty much for that very reason. Not had time because of this PC died to do anything beyond installing it yet. I have to admit, Elite Dangerous for me is a mixed bag. As far as its VR implementation goes, and especially for I can no longer play Elite Dangerous outside of VR. I just can't. I just get lost. The fact that I cannot look at the thing that I want to interact with, but I need to memorize all these different key binds that are able to use all these functions all at the same time is that requires an amount of preparation and learning the game. And this is, I think, the biggest lesson that Elite Dangerous has to offer here. If you play Elite Dangerous as a normal flat screen game, and a lot of flight sims and similar type of games all suffer from this, it takes a number of hours of playing the games and slowly, quote unquote, leveling up. Not leveling up your character, leveling up yourself to slowly become comfortable with what all the key presses are, so that you become fluent in, switching between I'm a privateer and I'm hunting pirates, or I switch to mining, or whatever other roles that space games of this type usually have. And you do the same game in VR, and it is just there. It is, I'm looking at something, and very quickly you learn to control the whole game with a minimum amount of buttons, and it all just makes sense. And there are flaws in that. It's not perfect, but it is an incredibly good example of how to do VR UI right. And I think, I think anybody can learn a lot from that. The game itself, for me, it's a lot of fun because, like I said, I'm playing it with my son. But it also has made me think back to the game that I was working on about 3 years ago, and actually wanting to pick that up, because Elite Dangerous is too big a scale for really enjoying it the way that I would enjoy playing something like this with my son. I would much rather go back to a Wing Commander style game, which of course was the original idea of what I wanted to build. But then, maybe with the multiplayer aspect where, my son can be my wingman or I'm his wingman, and we play through the missions together. That is more fun than doing it completely open world in my eyes. But I digress. The bottom line is, I think Elite Dangerous is just a very good example of how you can take a game where, when you look at it as for face value, VR doesn't actually add anything. And especially, again, going back to the racing simulator example, same sort of idea. If I have those screens around me, and especially with the purpose-built steering wheel, or for a flight sim, having a HOTAS, actually playing it, being able to see the screens and being able to see my steering wheel and being able to see my HOTAS and being able to see what the buttons are, is better than having a VR goggle on and being limited in your vision. Although I do think that pass-through has some unique options to offer in the future, where you might be able to still be in the virtual cockpit, but show enough of the real world. If you want, especially with like meta scene discovery mechanism, you could make sure that you use pass-through to still see your steering wheel and still see your HOTAS and still see your keyboard. That is a feature that I'm very interested in. But on face value, when you look at games like that, switching between playing it normal and playing it in VR, and especially with multiple screens around you, so that you do get that ability to look around, you're working on a scale where depth perception is much less interesting. It adds a tiny bit of immersion and realism that if you play that without that, and you play it in the 3-screen setup, you have the same level of immersion. The sense of depth isn't important in those games. And yet, Elite Dangerous, I would prefer to play in VR compared to having a multi-monitor setup to play it in, simply because of the fact that they have this UI sorted so well in VR. So that's the lesson to learn. Coming back to the original topic, because we're way on a tangent between those two extremes. On one side, you have a desktop game that you add a VR feature to, and it doesn't really change the game. It adds a little bit of immersion, and it can be enough to make that cool. To a game on the other side, which you can only do in VR. One of the ones that I was most surprised at, and again, this is another very early VR title, is Superhot. Especially when you think about that Superhot was originally not a VR game. I cannot phantom that this game was not a VR game from day one. It was a desktop game where slowing down of time was the main mechanism. Yet, moving it into VR and suddenly making the time slow down a factor of how much you're moving as a character. The more you move, the faster time speeds up again. The fact that you are now able to grab the things around you, the fact that you can see the bullets in bullet time go past you, is such a unique experience in VR that, again, it was originally a desktop game, but I cannot phantom playing that game in anything but VR. And that is, I think, for anybody who wants to get into VR, everybody wants to make VR games. That is the thing to ask yourself. Am I just reproducing a normal game in VR? And what am I adding here to make that VR game special or different? Why would someone just not stick to the desktop version of my game? Is VR just a little add-on that doesn't really improve my game? Or do I have a game loop? Do I have a game mechanic? Do I have something that makes my game so much better in VR that I don't want to play a game, or can't even envision playing that game on a flat screen? That is, I think, the holy grail almost of VR, and it's also where I'm sad that that holy grail has been found for games like Beat Saber, all these rhythm games that are now coming out in VR, because we found out that really, really works well in VR. And outside of arcades where you have physical drum machines that you drum on, or dance machines like Dance Dance Revolution, those games just aren't fun. Well, there are fun rhythm games, obviously, on flat screen, but there's something unique about playing those games in VR when they're done well. But it seems that is all the sort of games that are being made that are really special in VR, because we haven't found enough other gems and ideas that really work well in VR. And I'm overstating that a little bit, because there are plenty of other types of VR games that just really work well in VR. And but I think we need more, right? We need more concepts where people say, like, okay, this sort of mechanism is special in VR, can't be replicated outside of VR. That is the sort of games we should be making, and that is the sort of games that are going to convince people to get into VR, because they get an experience that you can get nowhere else. Okay, let me. I was an alpha back in 2015. Yeah, I remembered that it was that old. So yeah. Filipina from Italy. Hello. How are you going? 6 degrees of crispy bacon. Similarly, been wanting to play on the VR module for TIE Fighter converted X-Wing Alliance. Yes, that would be amazing. And at the same time, that reminds me also how this industry can really muck it all up. Now, I have to admit that I need to get back to this game at some point in time. Because I think that probably my memory is not doing it enough justice. But Squadrons, Star Wars Squadrons. my journey in VR, well, my journey in VR started way before, but my journey of actually owning VR hardware started with the PlayStation 4 PC, PlayStation VR headset. And obviously, one of the early demo games that you could play was the X-Wing Rogue One tie-in. And the X-Wing Rogue One tie-in is another example of how to do VR right. That demo is so incredibly polished from a visual standpoint of view, but also from a UI standpoint of view. From the moment that you start that game and look up at the at walking by, which gives you an immediate feeling like, I can only experience this in VR. I am seeing a freaking life-size at walker walk past. But then your mission select environment where you can look around the X-Wing and you can go, and again, this is all within the limitations of what the PlayStation VR could do. It's purely controller based. The whole thing was designed around the controller. And that design was really well thought out. And then you finally get inside of the X-Wing, and then the controls just make absolute sense. And it was just it was a joy to play. I played that demo until I completely memorized it from A to B. So I was very psyched for Star Wars Squadrons to come out, and I hated Star Wars Squadrons. And again, hate is a bad word. But I think the problem that Squadrons was or had was that EA did not believe that VR could carry that game. And as a result, Squadrons is a desktop game in the same genre as, X-Wing and TIE Fighter. With then VR tacked on. And again, from a visual point of view, except for the fact that everything outside of the missions isn't actually VR, you're seeing everything in basically a cinema mode, which is stupid and annoying and sad. But you get into your X-Wing, and again, visually it's amazing. Being in that world, being able to to see space around you and these beautiful set pieces that they've created for this game. But then control wise, and I do have to admit that I played Squadrons on PC with a joystick. But where on PC, and again, maybe it was better if I would have played it on PlayStation. I'm not sure if they would have done a better job there. But on PC, playing it with a joystick, the game assumed that I was playing it outside of VR, that I could see my keyboard, that I could be using my keyboard, that I was using a joystick for input. You could only configure the joystick correctly outside of VR. That was the other thing that, and again, I don't know, they might have fixed that at some point, but that was definitely a problem because I bought that game at launch. And I remember just being so disappointed at the quality difference between X-Wing Rogue One, the demo, and Squadrons as a full execution of that game, that I stopped playing it. I gave up on it, and that's really weird because it's one of my favorite genres of games to play. So, and again, I really want to make it very clear that I'm probably not doing that game justice because I gave up on it, and because I played it at launch and I played it on desktop where, again, they may not have thought things through, or maybe because of the fact that I was playing it with joystick instead of playing it with the gamepad, the game automatically switched over to a setup that was meant for playing it on desktop instead of playing it on VR. I don't know. So I may have given that that game a disservice, but at the same time, the fact that I had such a bad experience does show that they didn't think that through. And that's also the danger. That's also the thing that I really want to get out in the world for anybody who wants to go and build VR games is don't make that mistake that EA did. Don't make the mistake of, hey, the VR market is still relatively small compared to the desktop market. So I'm going to make a desktop game first, and I'm going to tack VR onto that desktop game. Do what Elite Dangerous did, which also was a desktop game that added VR support, but that added first-class VR support to their game. And I think that is absolutely something that people need to keep in mind in what they are doing. All right, that is a lot of talking and introduction, and you know, for anybody who's watching this, you know, weeks or months down the line, I do think that part of the introduction, going through our room scale tutorial and giving a little bit more background info on this. I hope I'm not going to lose my voice tonight. By the way, my throat is giving me a hard time at the moment. I think that is useful. I actually have been wanting to do, and have been planning to do for a while now, a proper tutorial purely focused on the character body-centric solution. I actually want to highlight that and turn that into, you know, a 10-minute video explaining the ins and outs of this, so that someone doesn't have to you know, watch through an hour's worth of stream and me just talking about it. So that is something that is in the future. That is something that I'm hoping to have time for very soon. But tonight we are going to start working on the missing one in here. And it's really interesting that we now have this segue, having talked about Elite Dangerous, having talked about X-Wing, having talked about, you know, Gran Turismo, is how in Godot do we set up a situation where the player is inside a moving vehicle and sitting in the pilot seat or the behind the steering wheel. So let's build that tonight. Now, part of that is going to be easy, and part of that is going to be hard. And the hard part really is that we're going to need some assets. And I think for tonight's stream, we're just going to use some blocks and keep it really, really simple. But obviously, to finish this demo, I want to build it out into something with actually some nicer assets. And we are being careful on what sort of assets we use in the Godot projects. And there is a part of me that wonders, should I do something with Trucktown? Here we go, Trucktown. Actually, let's open Trucktown just to be to have fun with that. Let's just save this. We're obviously going to change that and delete the things that we don't know. Don't want to keep. But let's for fun import Trucktown. Where are we? Here. Already. Because I'm not sure if I want to use Trucktown, but a lot of work was done on Trucktown to make it look nicer. And I actually haven't played it since they revamped this demo. So let's have a look at it. That does look already a lot better. So for those who are unaware of Trucktown, it is a little demo that comes in the Godot demos, and let's just why that's cool. Let's move that a bit softer. I hope that's a bit better. I don't really care about the sound. Anyway, this is a little demo where you drive a car around. You can just use your keyboard to steer this guy. And it's just a very simple demo of the vehicle body implementation in Godot. That allows you to so you can, for instance, also drive a truck. So now suddenly you've got a trailer behind you. Now these assets aren't usable for our situation. That's I'm gonna fall off. Godot trucking company. Hey. But obviously these assets wouldn't be useful for actually sitting inside of these. That said, the demo itself would actually be usable for what I want to do right now, and we could sit inside these things, but we don't have interiors, so while we might steal some stuff from here, that is probably not what we are going to be using for our little project for tonight. So let's go back here. Let's obviously delete our character body. 3D, bye-bye. We don't need you. There we go. So let's start with the absolute basics that we need. Excuse me. And I'm actually going to start with making our car work. And I'm also going to use the joystick because that makes it easy to use. It also means that I want to steal my trusty, or actually Malcolm's trusty. Where are you? Assets? Is it in there? Yeah, that is in there. So I'm actually gonna copy the assets, and I'm gonna copy the start VR from our movement demos because we're going to reuse those in this one as well. And I like to use this pattern thing because it's, you know, it looks better than just having nothing. So let's go and set up our scene with really the most simplest of shapes and make a little car run around. And the idea that I'm having eventually is to turn this into a little demo that where the car that you're driving is a little go-kart, and we're going to go through a little go-kart track. But we'll just use some very simple shapes right now to make that work. Excuse me. And then eventually we'll replace things with nicer assets. So the first thing that we're obviously going to do is we're going to add our sun in, we're going to add our environment in. That's just what we need. Why is that there? Shadows. That is, oh, I'm on 4.1. Should I go and do this in 4.2? No, I'm actually going to turn shadows off. I don't care about shadows. It messes with the lighting anyway, so I just care only about directional lighting. We can always come up with faking and tricking the shadow. Although one of the really cool things, really cool things, and something that we might play around with on stream as soon as the next dev build comes out of 4.3, that hopefully will indeed have this in it, because I can't remember if it's already merged. I think it's only the PR that's been submitted. But light mapping in the compatibility rendering is now working. And that means that we can do baked lighting, and the missing ingredients, the problem that we ran into is that we really need Vulkan to do the baking. So we now have this really cool feature that light mapping in the compatibility renderer is completely OpenGL, as it should be, but baking your light map now uses a Vulkan implementation inside of the OpenGL editor. So when you have your editor, obviously everything Vulkan is part of the editor. But even though we're in compatibility mode, it will bake everything. It'll start a little Vulkan session, and it will bake everything with beautiful, beautiful ray tracing or whatever exact technique. I think it's ray tracing that they're using to get the lighting, or at least to get all the shadow maps and lighting maps done. And then all of a sudden, you've got your baked maps, and then that is what we are actually using. And obviously, it's static lighting at that point in time, but it looks good. It looks very good, and that is definitely something that we want to use in VR. And I want to see how good that works on a Quest. Whether that implementation is efficient enough to run properly on a Quest, or if there are issues when we're running it that way. Because that is the secret to beautiful looking games on limited hardware like the Quest. So yeah, coming in a stream near you soon. Okay, so we have our world environment and our direct lines. We need something to drive on. So for now, we're just going to create a very simple floor. The way that I've done 100 times before is we start with a static body, we call that floor. And we're going to go and add a mesh instance to that. And that is going to be a plane. And we are going to make that plane nice and big. I kind of like subdividing this. It's not really needed, but I don't know. Old habits die hard. And for now, we're just going to, we're not going to bother with being difficult. We're just going to add a standard material. And we're going to go and use our pattern there. We're obviously going to scale our UV up a bit. Oops, that's the wrong one. We need this scale. There we go. So I don't know what how big that makes sense. Sorry, I just need a box mesh instance and mesh instance. I just need a box for reference. Oh yeah. Important to always have something at reference. So this is a meter by meter by meter, and I actually want our pattern to be in that same direction. So we're going to go back here, and we probably want to do something like this. Yeah, that's close enough. That is good enough, I think. The last thing that I want to do is I like this to be some kind of green. Just for now. Obviously, you know, eventually we'll have some sort of track on here, and I'm thinking about using something like a grid map or something like that. But for our intents and purposes of today, we just need a nice flat plane that we can drive on, and we're going to start with that, and then, you know, eventually we'll make a track out of tires or whatever. You know, again, it's a go-kart game. So now we also need a collision shape for that, obviously. Oops, collision shape. There you go, collision shape. And we are just going to use, because normally I use a box shape here, but I'm actually going to use what is called a world boundary shape. This is a new, well, it is actually not a new collision shape. It is a renamed collision shape. This used to be called the plane shape. But people have problems understanding exactly what that meant and what that did. But this is one of the most basic collision shapes possible, and that simply says you're only allowed to be on one side of this shape. This is a infinite sized plane, and you're only allowed to be above it. If you're below it, you're colliding. And what I really like about this one is that it is, in theory, impossible to fall through this floor. Excuse me, I am really starting to have a bit of problems with my throat, so I hope I'll last tonight. We'll see how long we hold on. We'll just keep on drinking water. I might have to refill the bottle that I have at some point. Here we go. There we go. All right. So yeah, so in theory that should mean that we should never be able to fall through the floor, even if we reach the end of our mesh instance of our plane. So yeah, there we go. We have a floor that we can now drive on. So now we need a car. Excuse me. And the car begins with a vehicle body. Boom, 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 boom. There we go. We're gonna move you up a little bit. I don't know how much. That might be a little bit too much, because of course I don't have a good model of a car right now, so I can't really judge scale. However, obviously our car does need a shape, and for now we are just going to use a box, but of course not a box like that, although that does give us somewhat of a idea of size. But we're going to make it a lot flatter. That will be 10 centimeters, so that will be something like that. And I'm actually surprised that it seems to be lying on the floor. What did I just use for a height? For this guy, Oh, 0.5. That's why. That's maybe a little bit too much. Something like that. That's good enough for now. How I think Z is length and X we can do for width. So we want to do that too. And we want to do that. Oh, this is a go-kart. What's the size of a go-kart? Size of a go-kart. Not in inches, please. So 55-inch wide. No, what is oh, and then 7 foot long. Oh, I love imperial stuff. How bloody annoying is that? So 55-inch is centimeters. Why does that not work? Does it not like, you know what, inch? There we go. 130, so 1.30 meters wide. So we're actually going to make that 1 meter wide. I do not want to go to 1.30 meters because I want to be our wheels on the outside. And again, you know, eventually I'm going to replace this by a proper go-kart mesh, or at least a very simple one. And the other one was 7 feet. So just over 2 meters. So let's say 2.1 meters. So that's our go-kart. Hello, go-kart. Okay. You know, and we just need a shape just to have something. That also means that we obviously want to have a collision shape for our vehicle. Hello, collision shape. And that should also be a box shape. And we're just going to size that the same as our box here. You know, we're not even going to be running into many things. Well, maybe eventually a firewall. We can keep it to a very simple shape. And eventually you'll probably make that collision shape a bit wider. What is important is that the collision shape does not extend too far down. But yeah, eventually we'll be able to hit walls. All right. So that is it as far as the just showing the car body. But we now need some wheels. So for that, we're going to go and look for our vehicle wheel. There we go. There is a wheel. And I'm going to move that there. I do want to do that a little bit more precise. No, we don't want it that far. There we go. And then we're going to move our wheel to the outside. There we go. Hello, wheel. And obviously our wheel is way too big, but we'll adjust that in a minute. Because our go-kart wheels are nice and small. Let's have a look. So I want to actually round that off nicely as well. There we go. Let's call that. Okay, is that forward or backwards? I'm not sure. Well, we can always swap them around. So left, forward, wheel. Yeah, then let's go and make sure that the wheel is actually smaller. Is that's way too small? Boom. Okay. There we go. So that's going to be our wheel size. Let's also make that visible. So let's go and get a mesh instance. And that is going to become a, is that a cylinder mesh? I think so, yes. Which we then need to rotate. Not on that one. Not on that one. On that one. Okay. And now for the size, so the same thing, we're gonna make that 0.2. Was that what we made this? Yep, that is what we made that. We're obviously gonna make that way less wide. That is good enough for what we need to do today. There we go. Hi, Vincent, how are you going? Imperial units spotted on half. Yeah, that's a good one, 6 degrees. Is Godot Jolt compatible with XR projects? Yes, it should be. It actually looks very likely that we're going to make a good switch over to that one, which is really cool. So yeah, as far as I'm aware, you can use Godot physics fine with Jolt. Could have even run. No, this is a demo project, so I want to keep that the way that it is. So yes, there are wheels here. Is there anything else that we don't want to go and overdo that on that? Next thing that I want to do, I'm going to do that on this level this time. I'm going to create again a standard material. We're not going to do anything fancy with our materials, but we are going to go and add our pattern. And the reason why I'm putting our pattern in here, even though that makes no sense for our wheel, is makes it easier to see whether the wheel is rotating the way that we want it to. Now we need to set up more things for our wheel, but because we have some tick boxes to do here. But I'm going to wait until we finish placing our wheels before we do that. So we're going to now do our right forward wheel. There we go. And that means that that's going to become there. That's now on that side. Then, you know what? We're just going to keep on duplicating all that. So this is going to be left back wheel. Let's put that back on the left and then on the back. And then obviously we're going to do right back wheel. Go. And that needs to be on the other side. Oops. How did I manage to do that? So our back wheels need to have traction. So this guy will have traction. This guy will have traction. And then on our front wheels, oops. And again, we might have just done this the wrong way around, but we'll solve that if that turns out to be, oh, that one is steering. And then this is the same thing, this one's steering. So we got 2 steering wheels and 2 traction wheels. Very cool. Okay. So, and now just temporary, we're going to add a normal game. So we're going to begin with making this work as a normal game, just so that we can see, is this doing what it is supposed to be doing? Oops. So here we are already seeing that, yeah, the camera is the right way. So we're looking that way down to the front. Let's actually go and do 2 viewports. Thank you very much. And I'm going to go to preview. And let everybody know that I am at this point going to apologize to my good friend. What's his name on Twitter? I always forget his name. What's your name, dude? Oh, look at that. Should be in here somewhere. Hello, I'm probably scrolling past that. I'm not. Pastor, yay, Pastor! I need to give you an apology, dude, because this is actually a use case where I would really like to install the new tiny camera plugin. So if we go to the asset library and we search for camera, ooh, there's a little, oh no, there we go. There should be a new plugin somewhere in here. At least I'm hoping that it was uploaded to there. And that suddenly also reminds me that I still need to add something to here, or update something in here. Oh, maybe it isn't in the asset library yet, but he's probably got it listed here as well. Oh, there's so much on Twitter, isn't there? I still call it Twitter, guys. I am not calling it X. Stupid name, X. By the way, if you guys are on Twitter and do not know about Passivstar yet, go and freaking follow Passivstar. He's doing some excellent cool stuff. Now, the thing that I'm looking for, if I'm not wrong, isn't actually his. But we had a long discussion on Twitter the other day around plugins, and for me, I believe that for the majority of plugins, and maybe even for the exceptions, it will be acceptable to have the plugins always installed in your project. And there is this want, a correct want, to make it so that if you are working on multiple projects of Godot, there are certain plugins that you use time and time again, is to then have a method to have access to those plugins all the time. And my solution at that point in time is, instead of having to download the plugins that you use each and every time you start a new project, is to actually download the plugins into a cache and then install them automatically when you start a new project, and just have a choice at that point in time and say, I want this one, this one, this one, this one. However, there was a plugin released, and that's the one that I was trying to find, and I can't remember the name of it, and I don't think it's on the asset library yet. But there is a plugin that, instead of having your camera preview in this big area here, is that you can actually put your camera preview in a little corner window. And I want to use that plugin right now, but I do not want to install that plugin as part of my project. I actually want that plugin to be active without having to add it into my project. So I owe Passistar an apology, because I argued for that would not be necessary, that is overkill. And here I have a situation where I wish we had that feature that he was advertising. And I actually am starting to see his point. And I'm starting to agree with his point that, yes, I would like to have plugins that are not part of my project, that are part of my editor. And yes, that means that whoever creates a plugin like that needs to be very careful about what they do, because they should not introduce anything into a game where the game suddenly becomes dependent on that project, but the game will not have access to the plugins. The project has a dependency on that plugin, and suddenly it doesn't have access to that plugin. And that is the risk for such an approach. But yeah, I'm going to react to where are we having that discussion? I can't even remember. Here, I'm actually going to react on his. There we go. That could lead to an interesting discussion on that, and hopefully an improvement on how we do things. Okay, so before we continue, the first thing that I want to do is I actually want to save this as a separate scene for my, and I'm actually already going to call it, no, I'm actually going to call it vehicle. And eventually that's going to become a base class from which we create our go-kart. So even though our everything is in here right now, we're eventually going to start moving some of this stuff into a subclass. Let's rename that there as well. And now we have a nice little thing here. I don't want to keep the two viewports. We're just going to go back to this one. Actually, all the arrows are now better visible, and that is confirming that we are actually going the wrong way. I knew it, because that is forward for the car, and we have made this the front of our car. So let's go and swap these guys around. That means that I'm going to move these guys over here. We're going to position those properly later. This now becomes minus. Oh, that doesn't work well. That's interesting. I think we just ran into a bug. Hey. Oh, it is. Because I selected like this, it has also double applied these things, I guess, because it shouldn't have applied that on there. Okay. Let's be a bit more careful here and do these two guys one at a time. We also need to swap left and right, by the way. Oops. There we go. And actually, let's go and do minus this one. And this one is plus. And this one is plus. And this one is minus. So that's our back wheel. And that also means that we obviously then need to turn our camera around. There we go. And then move our camera back. And now I wish I would have kept that. And do that. Good enough for what I need to do. All right. Okay, cool. So let's also put a script on this guy. Boink. And here we are just going to put our logic for controlling the car. And the nice thing about controlling our car, and then I just need to go back to his. I think a go-kart isn't 40 kilos, but let's just keep it that way. That's fine. No, angular, no, what? Oh, I'm looking at the wrong. So we are going to be working against or with motion. There we go. Sorry, I am having some things poking into me. This is what I hate about humid hot weather in Australia. Everything starts feeling weird. Anyway, so there are two things that we need to handle: our engine force and braking and our steering. And this is all stuff, because this is the other big difference from a game like this from a normal XR game. Even though we're going to be using OpenXR to play this inside of our headset once we have the basics all working, the control of the car, we are going to keep old-fashioned, because in a game like this, it is far more likely that your controls will be either a gamepad or a steering wheel or something like that, or maybe even mouse and keyboard, than your VR controllers. Not impossible, but more likely. And this is also where there is a quote-unquote weakness in OpenXR, because OpenXR has its own input handling system, which becomes our action map as the implementation in Godot. The implementation in Godot is nearly one-on-one with what OpenXR does. So we're piggybacking directly on that. We're bypassing Godot's input system because they are not compatible. And that is really the Achilles heel of OpenXR when it comes to input systems. OpenXR specifically chose to concentrate on the first person type of game. So games where you are the player, where you are walking around and working with your hands, and your controllers are tracking so that you know where your hands are, and you play those sort of games. And the whole action map system is completely geared to that. A game like flight sims and car simulators and that sort of thing, where you would likely want to mix specific XR type inputs with traditional inputs like joysticks and HOTASes and steering wheels and all those sort of things. That is the scenario where the people behind OpenXR said there is so much compromise needed to support that. And that's a long topic for another day, so I'm not going to go into this in too much detail. They said, okay, we're gonna leave that to game developers to figure out how they are going to combine those two different input systems. And that really basically means that if we do want to add control through our joysticks, let's say that we want to use our index controller and we want to control our car with that tiny little joystick on here, which would be horrible to control a car with, but it is possible. Then we actually need to have that duality in input systems. We need to check Godot's input system for gamepad, mouse, whatever inputs we're using, and we'll need to check our XR input separately to check if our controller inputs, our XR controller inputs, might be controlling our car. That's a compromise, and that was just a compromise that for, in my eyes, very good reasons, was an acceptable compromise. So for us today, we are actually not even going to bother using controllers. I know that there is, and actually he made an entry in the game jam based on the game that he was working on. But there is someone on our XR Discord who is building a flight sim game where he is actually controlling virtual flight sticks and a virtual HOTAS setup in the cockpit of his, I think it's an F-16 that he flies in this game, where you're manipulating this. So you've got your controller, and now you're grabbing your flight stick, your virtual flight sticks, and you're moving it around with. It's actually impressive. I really enjoyed it, but it's not the direction that I wanna go at. If I was, this is an example. This is a demo that I want to put online for everybody to sort of play around with, and obviously I'll give a shorthand version of this explanation as part of that. And I even plan that once this is finished to also write up a document page around this. Hello, you're done playing.
Yeah.
Wait with plugging that in before my computer goes haywire again. I'll plug it in later.
I just bought a $45 million spaceship.
Uh,
Now broke.
Well, the fact that you had that much money to splash on a spaceship is impressive.
Well, I mean, it's got 5 hard points, so it was worth it.
The happy bounty hunting. Yeah, we were talking about Elite Dangerous before. He was playing Elite Dangerous with my quest. Yay! Okay, Mara. So, all right, we'll talk about that for a little bit to make that clear. And even though I'm running ahead of myself a little bit with this, but let's just enable OpenXR just so that we have access to our action map. Go away. So the first thing that is important to know is when we are looking at the action map, the inputs are far more defined than Godot's input maps are. So we can have, triggers, which just give us a floating point input. We have obviously clicks, button presses. Those two exist in the input map. But now we also have joystick inputs, which you could do in the input map like the normal joysticks, which are just 2 floats. But then we go to poses. The input map has no idea what poses are. And finally, we also do output through the action map. The input map in Godot, if we open up the input map in Godot, where are you? Has no support for, yeah, just show the built-in action so that we can sort of see that. It has no support for that. The other thing is, when we are dealing with these guys, OpenXR, and actually we can see that in OpenXR when we start looking at the different types. We have defined paths. We have a left-hand controller, we have a right-hand controller. If we go to trackers, we can see that we have all these named things. The input map has device numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you have no idea which one is. It's first come, first serve. So having a mapping between these hard points and the almost old-fashioned approach in how inputs work in the input map, we're really hamstrung in making that work. But the killer thing, the thing that eventually was a nail in the coffin for this, because our original plan was actually enhancing the input map with the missing features that we needed for XR. But the thing that killed the idea of is the one thing that the input map has that the action map does not provide, and that is that the input map works in runtime. And by that I mean is all the inputs over here that lead to an action being triggered or an action giving access to values or state is handled by Godot. So first of all the input events that happen, we actually get, when I press the enter button, I'm getting an event enter button down. When I let go of the enter button, I get an event enter button up. And when the the input system detects that and knows that the enter button is linked to an action, it then also fires off that action, and you get an input action UI accept. That whole system is impossible in OpenXR because that whole system is built into the XR runtime, that is built into OpenXR itself. We are no longer responsible for that. So we do not get that information. We do not get the fact that a person has pressed the B button on the controller or the A button on the controller or the trigger on the controller. We don't get that information. What we get is the end result. If I've created an action called fire, then whatever is bound to that will eventually trigger fire, and that's what I'm getting. That's what I'm reacting to. So I actually only get to use the output of the system. And that suddenly hamstrings us in the fact that our whole input system in Godot does that in the game engine and therefore creates an existing system where if the user wants to change what the binding is, wants to say, I don't want this to be enter, I want this to be the third button on my HOTAS, then they can bind that in real time. You can build that interface and you do that. And that interface might already be in your game. And now you're going to add VR support to your game. And you suddenly learn that, hey, I can add all my VR things in here. And you add those in. And now the player starts the game. And the player says, I don't like that you did that on the B button. I want that to be on the A button. And they go into your existing logic and they change it over to the A button and nothing happens. Why? Because we cannot tell OpenXR of this change. We have registered our action map at the startup of our game. And the way that OpenXR works with this is, hey, here are the actions that my game expects. These things, these guys, are actually called suggested bindings. And the idea even is that when we deliver a game, is that we only deliver the action bindings, the interaction bindings, for the controllers that we've actually tested with. So we might actually end up, that one I probably should have kept, but we might end up with this. So our action map might look a little bit like this, because I have designed my game with a Microsoft motion control. So the controller that came with the WMR system, because I have an Acer or Lenovo headset, that's what I used to develop with. That's what I can test. That's the only action map that I supply. When I now put this game on Steam, and someone downloads this game from Steam and starts it up, and they happen to have an index controller, there is no binding for the index controller. You don't need a binding for the index controller, because what is OpenXR supposed to do, and I say you're supposed to do it, I'm not saying that they always do it, because there is some misunderstanding about what is expected here. But the XR runtime is supposed to say, hey, you only, you don't have an interaction profile for an index controller, but I have knowledge of all these other controllers. I can see that you have a mapping for a Microsoft motion controller. I have a mapping table that says, here's how you take the bindings for a motion controller, and here is how I supply it to the index controller. It is now going to lie to your game and say, this player has a Microsoft motion controller, while in reality, they have an index controller. And the player is going to nicely use their index controller to play, because everything is mimicking the other controller, and hopefully your game works. And the motion controller is a good example of, if you use it to the fullest, this one is not compatible, and you'll have a problem. But that's another story. So your game's none the wiser. Now, your game can't rebind something. In this case, it's very likely that your player says, well, I don't like this default mapping that Steam VR came up with. I want to customize this. Well, guess what? Steam VR lets you customize it. So we have this whole existing input system in Godot that has a whole lot of functionality that is going to clash with OpenXR saying, we've taken over ownership of that. We have that on the XR runtime side. And we are doing that on purpose. And this is where the magic comes in. And I'm going to reset this to default so that we have everything back, because it is very likely that I actually have an index controller mapping, because this setup is very straightforward. Most people actually be focusing on touch controllers, because we're all making standalone headsets and games nowadays. But it's very likely that you actually have a complete set. But what is always going to be missing here is the next controller that comes out. So Sony is about to release a new headset. Doesn't come with a controller that looks anything like this. And your game has absolutely no idea of that little ring and pointer thing that they came up with and how to interact with it. Well, guess what? If Sony adds in the interaction profiles and in their XR runtime make sure that they follow the OpenXR rules and make sure that the logic is in there, that if there is no interaction profile given by the application for the hardware being used, you need to look at the other profiles, find the best match, and then do a emulation of one of the interaction profiles that the game does provide. You can suddenly run games that might have been made years and years ago before your hardware was ever even designed. And those games will work because OpenXR is handling the input translations. But the bottom line is, we've now moved the responsibility from the game engine into the XR runtime. And that means that a system like Godot's input map system that takes the responsibility for itself, that doesn't fit. That clashes. You suddenly have to fit a square peg in a round hole, or the other way around. Was it a round peg in a square hole? Whichever way you go through. So that is the reason why. Now, that might change in the future. There is a lot of confusion that comes out of here. Your conclusion was also the initial conclusion that we made. Let's just add the input. One of the reasons why I love the action map system in OpenXR is because it tries to solve the same problem the input map solves in the same way the input map solves. It's just that it is now moved that responsibility somewhere else. But the action map system is just as good as Godot's input map system. The problem is it now competes with the input map system. So yeah, that is where a lot of people get stuck. And I think also where we have made our life heard. And again, this is really a topic for another. Well, it's actually a topic for a proper tutorial video that I have been wanting to make for a while now. And it's just for anybody who is interested in that part, there is actually an XR action map page that explains a lot of this stuff and how the action map is supposed to be used. But because we are setting up a default action map in Godot, which everybody gets the moment that you start a new VR game, and this is an action map that simply maps all the sort of inputs that we find in everything here to actions, and therefore means that, for instance, simple controls like a fallback controller, if you do have some new hardware that does not have an interaction profile, there is no translation, this is the bare minimum that needs to be supported. But obviously, this only triggers a small percentage of these actions. So if you rely on the existence of the, let's say, if you rely on the existence of the secondary joystick action, 90% of the controllers, and especially the simple, but almost every one of these does not support the secondary. The index controller has the trackpad as secondary, which is not just yippee, we have a secondary, but also it doesn't function like a full joystick. It really is up down with a little bit of left right action, but you can't really use it. And unfortunately, I don't have my Windows MR controllers here, but they obviously are also controllers that have both a primary and a secondary joystick. One is a proper trackpad, the other is a proper joystick, but they are full featured and they are mostly interchangeable. But the point being that most of the other ones don't have a secondary. So if you make logic in your game reliant on the secondary input, you're going to have a problem, because that is going to break on controllers that don't support it. But the bottom line is, there's one-on-one mapping that we do by default, and the reason why we have this, by the way, is because, of course, in the Godot 3 days, we started way before OpenXR was even designed. So in implementing OpenXR in Godot 3, we had to make it work the same way that OpenVR worked, and that the Oculus SDK worked, and that the VR API on the Quest worked, and et cetera, et cetera. And then going to Godot 4, where we properly build in the action map, we needed an action map that gave you an easy porting path from what, if you had your game already working in Godot 3, you wanted to port it to Godot 4. Like, for instance, XR tools needed to be ported to Godot 4. We needed an action map that worked the same way. This is not how OpenXR wants you to build an action map. So our default action map is actually a terrible, terrible example of an action map. So yeah, we are already putting people on the wrong foot there. But the problem is way bigger than what Godot is doing. The problem is industry-wide. There are a lot of people who are coming to OpenXR who are used to making their own input systems and their own binding systems, and who are getting very confused with an action map system being thrown on them, and specifically with an action map system being thrown on them that seems to be missing features. I mentioned before that if I want my B button to be my A button, I would need to have an interface on the runtime side to make that change, because I can do some dirty things on the game side to flip it around, especially when I do something like this where I map everything one-on-one. But if I follow the action map principles to the letter, I can't switch that. I've decided that the B button does X, and sorry for people who don't like the B button, but they're stuck with it. And that's got a lot of people on edge. Like, hey, I don't see that, because where are these rebinding interfaces? You tell me that that's how it's supposed to work. The only company that has a rebinding interface is Valve, and that one is fairly hidden. You need to know how to turn it on. And it is not the most user-friendly, because it's an interface that's actually designed during the OpenVR days, and it was originally designed mostly with developers in mind, not with users in mind. I like it, but there's a certain complexity layer on top of it that makes it an unfriendly system for users. So that is a problem. That has confused people. Now, the irony in this, because I have been fighting for a long time to get those rebinding systems into various runtimes, because I've been trying to make everybody in the industry see this problem. And it's a problem that, because here comes the really funky part of this. I see this problem from the times that I began with this. I see this problem from helping lots of people on the Godot Discord, starting with Godot for the first time, and running into, hey, this is what I'm used to doing in my games. How do I do this in Godot XR? And then sort of getting the story that I just told me, like, well, there's a hole here, you really can't. And then sort of panicking, and how am I going to deal with this? Well, the irony in this is, once you start building VR games, and once you get some experience, all of a sudden you realize that you don't need it, or you rarely need it. And the best example that I can give And the one that is a favorite example for rebinding systems is I have two controllers. This controller, right? Left, right. I'm right-handed. So I'm going to design my game as a right-handed person. And well, I'm sensitive enough that I appreciate my left-handed friends. I have plenty of those. So I tend to keep them in mind. That's one of the reasons why I'm a big fan of rebinding, UIs, because if I have an important function on the B button on my right-hand controller, and my left-handed friend says, I would really like to have that on my left-hand controller, then I like to add that feature. And I can't because there's a missing rebinding UI. However, as a VR developer, I have found out that I hate buttons. Buttons are evil. I want to have natural interaction. So I have my right-hand controller. And there is a device lying on the virtual table in my virtual world. And what do? I use my right hand and I grab that object. And now I have that object in my right hand. And as a right-handed person, I am now utilizing that object in my right hand. Guess what a left-handed person does? They like to use their left hand. They have a left-handed controller. They reach out to the object, the same object, no difference, not a single line of code changed. They reach out to the object and they grab the object. And now they're holding the object and they can do whatever they like to do with the object. VR has a natural solution for people who are right-handed and people who are left-handed, because if you design your game properly and you go to human interaction, you make sure that it is a natural interaction system, the player will simply use the hand that they prefer. We don't need a rebinding UI to rebind that I can only, because we're not only going to be able to grab objects with our right hand and leave that out of, no, we're going to be able to grab objects with whichever hand we want. But there is an exception, and the one that we are missing. And the one case where I still believe that rebinding UIs are important and inescapable. Same scenario. Right-handed. I want to be able to grab an object with my right hand. I am very cool, very happy. Let's say that I had an accident a couple of years ago and I lost control of my lower fingers. I cannot grab. So I want to use the trigger to grab. I want to go and reach out and I want to use my trigger. Or let's go even a step further. I am disabled in another way with my hands. And therefore, there is a company who designs a VR controller, not like this, but a completely different VR controller, specifically for whatever handicap, whatever disability I have with my hands, and allows me to use VR. What a brilliant thing. Let's say it's someone who's lost all their fingers or who's been in an accident and lost part of their hands, and they get a haptic device, a track device on their hand, or whatever is, or maybe they have a muscle disease, or who knows what is the reason why they can. A very good one for those people who like YouTubers and follow John Riggs. John Riggs had a brilliant example. He's a bigger guy and he has fairly big hands, and that is fine with his Oculus Quest. He's a big fan of his Oculus Quest. And then he got the PSVR 2. And the PSVR 2, so beautifully designed, such beautiful controllers. They have the beautiful halo. And you know what? Because of the design of the controller, he can't reach the B button because his finger gets stuck before he reaches the B button. And then he plays a game that he needs to use the B button. My point is, for people like that who have a reason, whatever reason, for not being able to use the controller in the designed way, those people need a rebinding UI. And it is, this is where, in my eyes, VR is so liberating, because let's go back to that situation of someone who cannot use their hands properly. And, they get a special made VR controller that, might work on different sort of inputs. And suddenly they can play a VR game like everybody else. And they suddenly have hands that they can use as any other person can use. And they can experience that in VR. But it requires that person to customize your game to their needs. And that is, I think, an oversight in VR at this point in time. And this is not an oversight just an OpenXR. Let's call a spade, especially our friends at Meta are, kind of guilty of it, because Meta hasn't changed the design of their controllers since the Rift days. Yes, the shape is different, the way they track them is different, but it's still 2 buttons, a joystick, a grip button, and a trigger. And because of that, Meta rightfully has drawn the conclusion, because this is why they do that, this is why they don't change the design, is they found the design that allows people to do what they need to do in VR. And by keeping that design consistent, they don't have to worry about differences from one Quest to another that break the games that were made. A Quest game that is made for the Quest 1, in theory, still works on the Quest 3. Might need to be recompiled, might need to have some drivers updated or some libraries updated, but in theory, the Quest 1 game, you don't need to change the game logic for that game to work. But the missing thing in it is that it's an overconfidence thing, because they follow this design pattern of keeping the interface the same over generations, and therefore creating stability over generations. They have less reason to think about the situations where people may need to change it. And again, this is the whole problem in VR. The whole reason that I just said is because so much is natural interaction. The difference between a right-handed person and a left-handed person is naturally solved by the way that VR works, unless you're an idiot and you don't use natural interaction in your game, and you make people always pick things up with their right hand. I can't believe why you would do that. But let's say that someone is builds a game that you can only pick up some certain objects with your right hand, then yeah, you need a rebinding UI to help left-handed people. But there's so much that comes natural that it's on face value removes the need for rebinding until you get to these edge cases. While for normal controllers, for these guys, and especially with the fact, you put a standard PC gamepad next to a PlayStation 4 or 5 gamepad next to an Xbox gamepad, yeah, they're similar, but they're not the same. So you need rebinding UIs to make sure that people can play your game on the controller that they have, because they could be buying a pro controller with 15 extra buttons, and they might want to bind those buttons. That doesn't exist in XR. And truth be told, I hope that will never exist. And that's my biggest fear. My biggest fear is that there's going to be some brainiac out there who suddenly goes like, why have all these VR controllers only have 2 buttons? That's so limiting. I'm used to game pads with 15 controllers. I'm going to make 15 buttons. I'm going to make an XR controller that has 15 buttons. And I hope he's not successful, because buttons are evil in my eyes. That's the biggest advice that I would give anybody who is getting into VR and making VR games, is use buttons as sparingly as possible. Use buttons for things that really, and the same actually with the joystick. We have no choice but to use the joysticks on the controllers to do locomotion, because else you're limited in movement. Although to be honest, the best XR games do not use the joystick, do not use the buttons. They designed the game around the fact that you have a fixed space that you need to move in. Beat Saber, Super Hot, Pistol Whip, all those games, they don't need buttons. They hardly use the grip and trigger button, and it's generally only in menus. Well, Pistol Whip, you obviously need the trigger to shoot the gun. Buttons are your enemy. There are no buttons on my hands, right? And the thing that makes VR special is that I am naturally interacting with my world. I am picking things up. I am interacting with the things. The buttons are only there because I want some tactility in certain games, like the feel of pressing a trigger, like the feel of grabbing something that's, obviously, especially with controllers, I'm not tracking whether I'm making a fist or not. So I'm actually got a button in here, and that is obviously, better latency wise than with normal hand tracking. This is the thing, there's a big discussion going on right now that hand tracking is going to replace controllers and we're not going to have controllers anymore. I don't think so. I do think that controllers will at some point be replaced by gloves. My ideal VR controller are tracked gloves because what I miss with hand tracking is not just the preciseness, the fact that hand tracking has a natural lag as AI is trying to understand where your fingers are and how your fingers are moving. And I have extra logic that needs to figure out that, yeah, when I make a fist, I'm obviously grabbing something. And when I do this with my finger, then I must be shooting my gun or whatever I'm holding. But gloves allow you to have tactility. With this, if I'm playing a gun game, I feel my controller. That is part of the immersion. My mind will translate this to being the handle of the gun or the handle of the lightsaber in Beat Saber. The fact that I'm holding something physical instead of not holding anything and just pretending that I'm holding something. The pretending that I'm holding lightsabers is immersion breaking. The pretending that my joystick is the lightsaber helps my immersion. So, and of course with gloves, especially once you have gloves that have haptics and resisting, so that the glove can stop you from closing your hand so that you have the illusion of grabbing something. Again, you have that immersion factor. So for games, I don't actually believe that hand tracking is the future. I think that hand tracking is going to break immersion, but gloves are going to be there. You look at AR, I can see the reason that you prefer hand tracking over controller tracking. So I think that those two will diverge. There will be two tracks. There will be applications where hand tracking is the ideal solution, and there will be use cases where a controller or a data glove or whatever future mechanic is there is going to be the priority over hand tracking. I don't think one is going to replace the other. I think they both will exist. I am going to catch up on chat, guys, because I've been talking my ears off, or your guys' ears off. Let's see how you guys are reacting to that. So yeah, Mero, I'm glad that you find that informative. Again, for a long time I've been wanting to actually put this in a video because I think this is incredibly important information. I think that it's causing a lot of confusion in the VR world, especially for people who are new to VR, who are trying to learn VR and get into it. The people who've been doing VR for the last 7, 10, well, almost 15 years now, if you started with the very first, wrist prototypes when Paul Malachy put his first prototypes duct tape together on Kickstarter, or actually for some people it started earlier than that. They're way past that point. They have so much experience. They understand that this is all a distraction. And when they look at something like the action map, they go like, oh yeah, that solves a whole bunch of problems, especially when they're scratch building an application. The action map shines when you're scratch building an application, when you're not using a game engine. And again, this is also for me another really important reason why we built the action map as is in Godot and not try and combine it with our existing input map, because well, I know for sure that in Unity that's road, and I think Unreal as well, and it was actually causing them a whole lot of problems. It's actually made things harder for exactly the same reasons that I said why we decided not to do it. So yeah, there is that. Anyway, I do believe that that is something something that I would do want to, you know, put on paper or put into a video properly, so that people don't have to go through a 2-hour live stream and figure out what I'm all on about. 6 degrees of crispy bacon. Message returned, but you agree with Marrow. Very cool. So to extent the valve rebind is more like a hacky situation to this problem. It is and it isn't. I'm actually I can probably how do I no, I don't think I've got access to it right now very easily. I don't have it up and running yet. I might show it later on once we're in VR. I don't want to do a whole bunch of things right now just to get the little window open. The UI itself, I actually wanted to mimic the UI. It is in the background. You know, these are just tables right now, but in the background, I have a system here that's currently not utilized, where it will be possible to create an alternative interface for a specific controller. And my idea was always that, you know, all the standard ones that aren't, you know, we just don't have the time to really invest in, would just keep using this, or that we just quickly want to add. But then, for instance, for a touch controller, because that's what the majority of users use, I actually wanted to do an interface that's similar to what Valve did, where you actually get a diagram of the controller, where the actual inputs are, so that, you know, because, you know, most people have no idea what's a palm pose, you know, what's an aim pose, what's a grip pose. And you can then read the documentation and get a bit more information, but we can visualize that information. The same with all these buttons. You know, where is the X button? Where is the Y button? Where is the trigger? Well, those are pretty easy to understand, but there are some controllers out there that do start to get towards the too many inputs, but then have that as a graphical representation. And that is something that the Valve rebinding interface does really, really well. The part that is, in my eyes, confusing is if I'm a user and I am using an index controller and I want to rebind it, I just want to open up a window, that final window that I'm talking about, where I see my controller and I see the bindings for the controller, and I just want to change those bindings. In order to get to that window, however, I need to open up a window that shows me all the profiles, you know, all the ones that I don't care about because they're part of the action map. It allows me then to create a custom profile where I need to know which thing to then clone, and then I need to edit that, and now I get the interface that allows me to change. And the whole idea here that Valve had, and I get why they're doing this, is they wanted to get to a point where if there is a game, and this, you know, there's a whole bunch of history behind this as well, especially in the beginning days of VR, this situation was way worse than it is today. You know, there were so many games that came out in those early days that would only support the Vive ones, and where no matter how, and I'm actually talking about the OpenVR days now, no matter how good a job Valve did in trying to, you know, if you then had the Oculus Rift, in trying to map the inputs of the Vive ones to the touch controller, it was never perfect. You know, it was even worse if the game was made by someone who was using Windows WMR websets, and they were using both the thumbsticks and the trackpad. Because how do you map that to a Vive 1? Vive 1 has half the inputs as the MS motion controller had. So the whole idea that Valve had at that point in time is that they would do the best job they could automatically, and then have the rebinding UI for people to then fix up the automatic mapping so that the game would actually work, even though it was designed for a different platform. And then, because it had that whole profile UI, and you now had created your custom profile, you can then share that profile with other users so that other users who also have the same headset as you don't have to all go through it themselves. They can go to the community and say, hey, here's another community user who has the same headset as I, has got the same problems as I have, and here's a nice profile I can download, and I can play this game. And they wanted to promote the whole ecosystem around that. But I think the problem that introduced is that they came up with an interface that is way too confusing. And not user-friendly. It's great towards developers because for me, and again, I'm talking about the OpenVR days now, because that's how early on Valve had the rebinding UI or the whole profile set, because they didn't just use that interface for rebinding. They actually created that interface originally that I, as a developer, had a UI that I could configure all my bindings for my game. And because I could see the controllers, I could figure out, what the best bindings were. I could then save that profile, and now I can include that profile with my game, and I can ship it. And that was the original base idea. And then, of course, the customability for users came on top of that, and so it's a very developer-driven interface. So the mapping interface itself, I find beautiful. It's just the fluff around it. It's not very user-friendly. Sorry, Valve, but that is my opinion on that. So yeah. Okay, 60% spot on bars, rate accessibility aspect. I'm not veer off again, but this is relevant to my interest. Well, I'm glad that you found my my information valuable in that that respect. Okay, let me oil my throat a little bit more, and then we're gonna go back at making our little box cart. Because right now it's just a box cart. While we're in the OpenXR action map, because like I said, we're actually not going to be using the OpenXR action map. What I like to do, because once OpenXR is enabled, obviously we are going to have an action map to deal with. I like to clear out the action map with only the default. Hold on. Only the default pose in place and the haptics in place. So I want to have an empty action set, and then the only thing that I want to add is my simple controller. And we're going to add our default pose to our aim pose here as well. And we're going to add our haptic to our haptic. And that is going to be our action map. And we're not going to actually be using the action map, but I do like setting up an action map because that at least allows the OpenXR runtime to, because your controllers are likely going to be turned on, it does allow them to latch onto that. And while we are going to be ignoring them for now, we do have, the base information in there. And with this setup, the simple controller will, work for any controller. The only thing is hand tracking is currently a miss there, but that's the story for another day. But again, we're not even going to be using those inputs, so we're just going to have that in place, and it's just to at least have something to communicate to OpenXR, and then we're just going to ignore whatever is in there. Now with that all set up, I am going to go back here to OpenXR. And I'm going to disable that for now again. That means that we're going to have to restart. Now, that's not going to delete my my action map. So that's now already set up for once we re-enable that. That looks like it actually crashed. Very good. Here we go. So our OpenXR action map is gone, but it's still there as a file. But at least OpenXR doesn't start, because obviously when I run this, I just want to go in here and actually, I think I'm on main, so that's good. So just wanted to start this, and we already can see that there is already a problem. My wheels are sinking through the ground, and that is because our default settings for what we've just created, these are based on really big wheels. And we need tiny wheels. So so obviously, you can see that our rest length is already putting everything on the ground. So we probably want a very small rest length. I don't think I care about that. I don't care about that. So I'm just going to do the same thing for everything. And to be honest, one of the things that I need to look into, this is actually a go-kart. And I don't know if you guys have ever driven go-karts, but go-karts actually don't have suspension. The wheels are, they're just fixed to the chassis. There are no those springs and stuff like that. So the fact that we are creating some amount of travel here, it's still going all the way down. So what else do we need to do in order to make this happy? Okay, so we also have the travel here that we want to. We're gonna make the travel really, really small. We're probably going to get the stiffness really, really high. I was expecting that to work by now. How high up are we with this thing? Again? No, should be this one. 0.2. That's why we had a 0.2 thing. This one is 0.1, so we should have a 10 centimeter clearance. And with this, we are moving 2 centimeters down and we have 1 centimeter extra clearance. So we should still be 2 centimeters off the ground at the least. So yeah, probably just put the stiffness nice and high. Because again, we don't have suspension on this thing, but I still want to use a vehicle body because it comes with animating the wheels and animating the steering, and it has all the making the vehicle move stuff in there. No, still goes straight through. We have lots of force, so that's cool. I think I might want to maximize the damping, because that I think should take out any springy action, which would be very, very useful for a go-kart. But it's still going through. It's just sinking straight through. What am I missing here? The body comes to rest on the floor, so our collision shape on the floor works. We could just for fun make sure that we have a bit higher starting, just in case that we're just already we're not already to the floor. I'm going to change that back eventually, by the way, once we get this right. Don't care about that. Don't care about that right now. Yeah, do you think stiffness really, really, really high? Let's say I need 80. Probably that is exactly what we need because, whoops, why am I having my fingers on the wrong buttons? And again, also keep in mind that our mass is 40 kilograms, so no, it just does not want to do this. So now obviously we got 40 kilograms as force, so 6,000 kilograms per meter per square is more than enough. What if I just put my travel to 0? And that actually also means that I want to put my rest length on 0. So basically we're now saying, our wheels don't compress, buddy. Not possible. Dunk, dunk. Dunk. Think you got them all? And even then, it just goes straight through. What am I missing? What am I doing wrong? Yeah, let's go way high. Maybe not having any travel at all will, because that's one of the reasons why I did keep my travel. And why I actually want to have my rest length in there as well. Is that we might be ending up with divide by zeros. That's still there. So maybe our max force. Yeah, higher than the quarter of the. Oh, it's 40, and just go way up with that. You know, for all I know, not because the truck thing, the truck demo proved that it's working. Well, that's what I'm putting my stiffness really now. I think I'm going to do put that back because this might just make it impossible for it to do the simulation. So let's just undo these guys. Now, one thing that I'm going to do as well. Okay, so just in case, because again, I know that there were problems with the world bound. So let's say if I make that a box, and I make that 1,000, keep that on 1, but that means that I now need to move that down by half so that it's flush. Does that make a difference? Nope, that does not make a difference. So that is not our problem. So let's go back to just keeping it a world boundary because that is much safer. Yeah, I know, but I always have problems with that, so I'm always a bit careful with this. All right. What if I make that really crazy high? Well, it's bouncing on something, but oh yeah, because I moved that bloody thing half a centimeter lower, didn't I? Let's put it back to 0, please. Okay, so that's now there. So that's become very, very bouncy. So we're getting somewhere. Let's go back to 200 because maybe. Okay, this just doesn't make sense for a 40-kilogram car. Hello, 500. What's that going to do? It is definitely going to bounce, but it's going to make it very. Okay, so let's put the dampening way up. What does that do? Okay, I think it's going to be a little bit unstable, but let's just see what that does. I actually want to put the rest length just on 0. Oh, still running. It's funny how it actually goes slightly in. This vehicle simulation is a bit wicked. Obviously, we can put our car back on the ground so that it doesn't drop down and go bounce. There we go. At least we have it standing on the ground. Better than nothing. All right, time to configure our input map. All right, don't show built-in actions. Now, this is where things go really funky on how the action map works. So we're going to do turn left, boink. We're going to add an action turn right. We're going to put an action accelerate. And we're going to have an action brake. Okay. So for our turn left, let's just do at least an A. But we're also going to go and put that one in. So I was just using my joystick to put an input. So for right, we're going to go D. But for right, we're also going to go right. So joystick 0, left axis left, joystick 0 left, left stick right, joystick 0 right. Interesting how it doubles that up. Okay, then for accelerate, I am going to obviously do W. But I'm also going to use my right trigger to accelerate. And then to brake, I'm obviously going to do S, just a normal West D sort of thing. but I'm going to use my left trigger to break. Okay. Cool. So those are our inputs. Time to put some logic together. Am I going to do this in process or physics process? I'm just going to do this in process because of the way that these inputs work anyway. I think that is fine. So the first thing that we need to figure out is what our steering is. So we're just going to say if our steering is input dots. Now I always forget. Let's actually go and have a look at our input help. Because there is one where we can give both our left and our right input, and that gives us a nice value. So this is both X and Y, but I just want the one that doesn't have the Y in there. There should be a get with just the X and Y, I thought. Maybe not. Well, I guess we can kind of do either or. I thought there was one where you can just do one axis. Hold on. Am I blind? Oh, here. Get axes. Negative action, positive. That's what I want. Okay. So it's going to be get axes. And that is obviously going to be turn left. And then turn right. Cool. And as far as I'm aware, that gives us a float. But if we're using keyboards, it's going to be ones and zeros. And if it's going to be, hold on, I need to sneeze. Excuse me. Oh. All right. But if it's my joystick, it's going to be analog input, which is cool. So I'm using my left joystick to steer. Maybe I should have used my right joystick. I don't know what's smart there. I might actually change it to the right because I was originally planning to use the right for forward back. Because I'm using triggers, I actually want to steer on my right one. So I'm going to take that one away, and that's going to be like that. And I'm going to take that one away. Oh, I could have done the edit, actually. That would actually be fine. All right, there we go. So I'm going to use my other one. Importance of rebinding UIs. That's something the user will want to choose. So let's start with our steering. And our steering is simply going to be an angle degree on this. So we're going to go from -1 to +1. So we can actually simply say that steering, we are I'm going to call that one steering input. I kind of like putting that in two because if there's a problem, we can debug. And it's easier to see what the values are that we're getting in versus what we get out. So, and this is something where that cons bar. Go. And it's degrees here, but it needs to be radians here. So deg to rad. So let's say that we have a maximum steering angle of 45. Okay, let's see what happens. Can we steer? Doesn't seem to work. Constant name, so it's not constr. Pay attention to your error messages. Yeah. Okay, it's going the wrong way. I don't care that it's clipping into the body. That's not important for now. But it also works with the joystick. Now, obviously, one of the things that we probably want to do is LURP it. so that it doesn't go so spontaneous. But that we have like a max speed of rotation. That's for another day. We're gonna keep it nice and simple here. However, we're obviously going to do the negative of the steering angle. And there we go. Now we're steering the right way. Cool. We have steering action. Yeah, Smarty, it is. In theory, the vehicle body works really nice. I've done a lot of testing and playing around with it. It worked pretty decently at some point, so I don't know what's changed. Whether it's us going from Bullet back to Godot physics, or another reason why it's gotten very temperamental. With a lot of trial and error, you can get there. But there's definitely weird bits in the calculation that that make me have some question marks with the implementation. Now, obviously, there are plans to move Godot towards Jolts now that the Jolt plugin has proven to be very stable and successful. And that will change things again. So it makes sense to wait until that's done before revisiting the vehicle body. But just to segue on a discussion that we had way at the beginning of the stream, and on the subject of plugins, I'm a big proponent of plugins, of a plugin structure for Godot. I love it, for instance, that we now have multiple terrain plugins, each with their strengths and weaknesses, and that you have a choice in what sort of terrain plugin you want to use. And I think, when I look at the physics engine, the fact that Jolt is a plugin I actually really like. So I'm of the position that we should just leave it there. And if we really don't like the Godot physics, just remove the physics, which means that Godot doesn't have a built-in physics engine. It just has the physics server so that you can plug in a physics engine. But then you need to find a way to deliver the Jolt physics engine with the Godot game engine so that you don't have, a missing part of the game engine. And that is also the reasoning why there's talk now of actually replacing the built-in physics engine with Jolt and making Jolt core. Now that is an ongoing discussion at the moment. Who knows where that will end and where that will go? Jolt in the core would be amazing. Again, I prefer the plugins system, but in the end, it doesn't matter as long as we have access to a really good physics engine. And I think once that sort of has died down and the decision has been made on there, then it's a good time to look back at the vehicle body code and either polish it up so that it works better, or look at alternative. There are lots of better vehicle simulation approaches that you can implement with something like Jolt. However, I also believe that should be plugins. I believe that the vehicle body and vehicle wheel should be components from a plugin so that they can be maintained and managed separately from the Godot core. And it also becomes easier to swap out, a raycast-based version of vehicle with another method of implementing vehicle physics. So that's my opinion on it. The reason why I'm not using 4.2 is because this project is going to be part of the Godot demo projects, or I hope to be part of the Godot demo projects repo, and we try to keep this at as low as possible Godot version. I might update it to 4.2. I don't really know where the rest of the team stands on that. There are a couple of examples in here, like for instance the compute demo that's in here that actually requires 4.2. And on the XR side, I am working on an example around hand tracking That will require 4.3. We are just using features that we've only recently added to Godot. So obviously there you don't have a choice. But there's no reason why this demo won't be sufficient in 4.1. I don't want to go to 4.0 because there's XR things that we fixed in 4.1. But yeah, I'm trying to stick with an as low as possible version to make sure that as many people can use this demo to get inspiration from. All right, so that's the steering input. Now for the braking and steering. Now, what I'm going to do for that, I'm actually going to put in a reverse value here. And what we're going to do here is we're going to say engine force is input dot get okay, let's have a look at which one that is again. Because we don't want to do, because that's going back to the raw data. We want it to work on the action. Is it get action strength? Returns a value between 0 and 1 representing the intensity of the given action. In a joypad, for example, running away the axis analog sticks 1, 2 is from the dead zone, the closer the run. If the action is mapped to a control that has no axis, as the keyboard, the value will be 0 or 1. Exact message files, it ignores additional input modifiers for that and that. And the direction. Okay, I think that is the one that we want. Dot get action strength. And this is accelerate. Okay, but here I want to do not reverse, else we're going to do break. And that'll become, no, you know what? Actually, I want to do that differently. I want to do it like this. If not reverse, then we do that, else, because then we can put a different, we can put different values there. And then the same with this, break is the braking force. And then obviously here, we're going to go the other way. We're going to say accelerate. So we'll need to add a check to switch into reverse and back into forward motion. But that's something we'll add in a bit. So here we're going to do forward acceleration. Oops. Is give us. So that's going to be that. And we'll fine tune those values, of course. Okay. Backward acceleration. So I don't want to be able to back up very fast. And we're going to say const brake force. And I have no idea what are good values here. So we might be doing totally dumb values at the moment. Now, obviously, we don't have a reverse check, so we should only be able to move forward. So that's moving forward. And I can brake. Well, the brake force is definitely good because I'm the lightest touch I'm braking. So I guess my brake force can be a lot less. But my forward acceleration, I think that is actually a good backwards acceleration. We're going to make our forward acceleration quite a bit more. There we go. We can already drive around. Very cool. That feels much better brake-wise. Yeah, I can control braking much better. And not just slowly rolls. Okay. Okay. So what we're now going to do is we're going to see where do we have that? Should be a property on rigid body. Velocity. Yeah, linear velocity. Is that it? Cool. We're only going to be reading this. So what we're going to do here is we're going to say if linear velocity, let's assume that 0.1 is good. We might make that a constant eventually as well. So if we're standing still or near standing still, we're going to check if input is action just pressed, brake. So if we've just pressed our brake while we are not moving, we are going to make reverse true. Else, oops, we're going to check if we're accelerating and we've just pressed our accelerator button, we're going to set reverse false. So what does this do? This means, oh yeah, nowadays that is a function of linear velocity. So we can just do it like that. Okay, here we go. So I can still move forward. Now I can brake, but I stop. Now I need to let go of my brake, and I need to press my brake again. I now need to reverse the direction of that. Now the other thing that I want to do is that if my linear velocity is smaller than that, I actually want to apply a really small brake force. No, I can't do that because actually, yes. I'm actually going to say that over here. Auto brake force is going to be 0. And then if we are almost standing still, we're going to give that a little bit of extra brake, whatever we're doing here. And that is just to make sure that, because the physics in Godot has a tendency that if we don't have any input, is that our car slowly keeps braking. So obviously, when we're reversing, we want to also go in the other direction. So let's see if that works now. So we can move forward. Now I can brake. I'm standing still. I need to let go. But press again. I can reverse. And the same thing. I can brake now with my right finger. But I need to let go before I can go forward. And that's how we switch between reverse and forward. Okay. So we have the basics of our vehicle working right now on a plane. So obviously we need a nicer track for this, but we're going to do this in VR. So I'm going to remove my normal camera here. There we go. And we are going to go and put in our XR rig. So now we can go back to our project and we can go and let's see. We can go back to general and we can go back to OpenXR and obviously enable OpenXR. We also want to enable our shaders. Do we want to do anything else? No, because we don't have a bunch of options here, so that's cool. All right. Now in our main, we are going to add a node 3D. I'm going to call that start VR. And just like our other projects, we're going to go and assign our start VR thing to that. We're eventually going to do something with the pose recentered, but we're going to leave that alone for now. I'm just checking if there's anything in here that still needed to be updated. I don't think so. This is all working just fine. Very cool, very cool. I'm super happy with this. Is that bug fixed in this one? Yes, it is. Very cool. All right, and I am actually going to go and put that even on 144. The higher our frame rate, the better. So this is going to start up our XR server and do all the stuff, and it's just going to make our main viewport, our viewport, super honky-dory. We are very happy with this. But we're going to assume that we always have a vehicle. Now, remember, I said that I'm going to make that our base class. However, there could be scenarios when you make a bigger game that you might be in scenes where there is not a vehicle. Now, that's one of the reasons why we have the start VR script over here. And actually, at some point, I should probably change that to not use a node 3D, but even a normal node. You could even autoload this script. I like having it in my scene. The advantage of autoloading it is that you can use Godot's built-in scene changer. I always build my own scene changer if I have a multi-level game. Or, of course, you use the staging system that we added into Extra Tools that does a more elaborate one. But for our demo here, we're obviously going to assume that we always have our vehicle that we control, which eventually is going to be a subclass of the vehicle body. So that means that at least for our main game, our XR nodes should be there. Now, if we are in a situation where we do want to have a loading screen and then a main menu screen or an environment. Hopefully it's not a screen, but it's a nice 3D environment. Let's say that you start the game in your garage, and there you can choose which car you want to have. You can see the car in front of you, and then you need to get into the car or interact with the car in order to actually go out on track. Then it's very important to know that there is a current tick box here. And only one XR origin can be current at any given time. So you can have XR origins in all your different scenes. And just as you switch from one to the other, you make the right origin point current. And the same with the camera. So obviously we need an XR camera here. We are going to go and make our camera current. Now, in this case, this is our only camera and our only origin point, so they should automatically become active, and then we're all good. We're all hunky-dory. So, now, we obviously don't have a seat on this thing yet. We do know that we actually need to be the other way around. Let's go and make that a nice 180. But the thing that I'm going to do, and this might seem strange at this point in time, but we're gonna make reason out of madness. But again, I'm going to assume that this is a go-kart, so we're going to have a person sitting here, and we're going to go and put this right where the head is. All right. Now, something that's still missing here, and that actually needs to be added, and it's something that's coming in 4.3. No, it is here, reference stage. So I have two options right now. One is the thing that I've done in my vehicle demo, where I'm handling the recentering logic. Because obviously, what is going to happen now if I do room scale default, and we'll just do that for fun. We're obviously not going to have our camera at this point in time. If we run this thing, and now this beautiful thing is going to go and figure out where we are. And once they start tracking, and it's not tracking yet, then yeah, I'm nowhere near where. First of all, I'm much higher. And we'll actually put a little marker there in a minute so that we can see how far we are. But I'm also nicely to the side of my go-kart. And that is because obviously, my camera, my headset, is being tracked in relation to whatever my tracking space has determined is the center of my room. Let's put it back. And it might even, do that based on wherever the headset was when it was turned on. Okay. Before I continue with this, just for a test, just to make this a little bit clearer, that we know where we are. Actually, I should do that differently. I'm going to put you over there. Then I'm going to go and 0 you out. Don't actually care about that. I got to make this a bit smaller. That's way too big. I'm going to make it like that. But now I am going to move that here so that it's not based on my origin point, not based on my camera. And now if I run it again, let me grab my headset before we start. Okay. Come on, track it. Why are you not tracking my headset? Hello. Hello. There we go. Okay, why is my... Oh, you go. So we can see how far off we are to where we're expecting to be. Now, what I did in vehicle demo, my original Godot 3 racing game that I was working on a year or two ago, or maybe even longer, I used our built-in function called center on HMD, which takes a rotation mode and a keep height. So if you set the rotation mode to reset but keep tilt, and you set keep height to false, it would position or it would reposition the XR camera on top of the XR origin point looking forward. So you could call this at startup, or you would usually delay it a little bit until you know where, that the tracking has started. And you could call this when the user requests a pose recentered. So it's usually coupled to the little menu, and especially with Quest, I think it is your right hand meta button on your controller. If you hold that for a few seconds, that triggers the recenter, and we then get this this signal that we meet recentering. However, OpenXR, because again, this is all, the whole center on that HMD was all built before OpenXR was even a thing. OpenXR actually has, and I think this wasn't even in the first regional spec, I think this behavior became in later, has again delegated that to the XR runtime. So on stage, when you recenter, nothing happens. And this was a lot of confusion of people in the beginning, because in the very early days of OpenXR, it did actually do some recentering, and I think, if I remember correctly, it recentered the direction that you were looking. But stage was supposed to be where your tracking matches your real space. And this became especially important when more AR vendors started using OpenXR, and when Meta introduced pass-through, because you cannot recenter in pass-through, or you can, but there are consequences that you need to be aware. Because obviously, if you do something like center on HMD and you just plug wherever your player is and you put them bunk on the XR origin point, that throws everything in the real world out of proportions. And the real world is really only tracking the headset and your controllers, your hands. So yeah, there were some little issues, and those were all more clearly defined over the years, to at this point where we are, that if you do a pose recenter on the reference space stage, it actually doesn't do anything on the headset. At that point in time, you have to react to pose recentered. and do the right thing, which we often do. Like we do it in X schools and we do it in some other places. However, there is another reference space. It's called local. And in 4.3, a new reference space is going to be added to this that is currently being tested. Our good friend David Snowpack is adding support for that, if I'm not mistaken. Is a new reference space that was recently added to OpenXR, which is called local floor. So local, which we are going to use today, means that at startup and after recentering, the headset is going to be on the origin point, which is exactly what we want here. Once you start it, you can freely move around and move away from that center point. So even in this example, I can stand up and walk away from my car, from my go-kart. And, we're going to do that, by the way, because it's hilarious. Unfortunately, because we don't have a track, it's not as hilarious as when we're on a track and we're actually driving. Because it's literally like stepping out of your car while you're going down the freeway at 100 kilometers an hour, but then without, falling on the floor and dying. There's some funky things that we can do that. But at least at startup, you are at that position. And whenever you hit your recenter point, you are being recentered. So whatever way I'm facing and wherever I'm standing in my room, boom, I'm now at the origin point. The local floor option that is being added is a combination of the two. So it has that recenter logic. It is going to place the player on top of the XR origin point at startup, and whenever you recenter, again, you can walk away from that, and then obviously you're no longer centered on the XR origin. That's the place where people can start making mistakes and suddenly think, oh, my XR origin point is the location of my player now. So I don't need to do all the fancy room scale stuff that Baz taught me. I can just throw that out the door. No, don't throw that out the door, because your user can still walk away from that center point. It's just your starting point is now nicely on XR origin. So instead of your XR origin being some center place in your room that you don't have any control over, you can at least know for sure that when your game starts, your player starts on the XR origin. But the local floor part of it is you do keep your height. So instead of the camera being placed right on the origin point, it's going to be on the origin point, but at the height of the player. And again, I'm sitting down right now, so my height will be a meter or so off the ground. If I'm standing up, it will be 1.5 meters or something off the ground, but I'll be on that XR origin point. So for our game right now, we want to do that on local. I've never tried this before, so this is all theory. Might not work, but if it works the way that it's advocated, and I haven't, ever, for all I know, I've never implemented this properly. Although looking at the changes that David was making, I think it's always worked. This should do exactly what we want, and we don't actually have to use center on HMD and do it ourselves. It will do it for us. Okay, let me just quickly check on it. Hey Lungo, how are you? Thank you for liking my videos. That's really cool. And Ronnie edits. Oh, I'm gonna watch you as I'm making a game too. Oh, look at that. Multitasking. Very good. I hope you're making a nice game. Feel free to tell us about it. I'm always interested in hearing what people are working on. So, if I play this, now I can sort of see the ball. See, I'm right at the ball. Now, again, I can move away from that, and I can, want to be careful because I don't want to trip over anything on my floor, but I can stand up. Now, I am above my ball. So as you can see, I can still move around. I don't want to move too far because I'll trip over my my fan behind me. But my starting position is exactly where I want it. Now the other thing that I want to try, and for this I actually need my other controller. I think is my right hand controller. I think so. So let's go and put my controller on. This is kind of also why it is important that we do have an action map, even though we're not using it. But once my controller is here, I should be able to hold my recenter button. And that actually doesn't work on this. I actually went to, oh yeah, this is because on Valve it works differently. So I need to just press it once, and you guys can't see it. I'm now actually inside the menu, Steam VR menu, and one of the options on the Steam VR menu is recenter. And I'm going to sit on purpose a bit like this. So it's now saying 2, 1, and recenter. Boom, it's recentered right there. And I'm obviously not going to stand up and stand somewhere completely different. But if I was standing up, then boom, I would be back at the place where I want to be. And let's go and do that again while I'm sitting normal. 3, 2, 1, boom, recentered. So without writing any code, like I did before with, and again, I'll just put my my headset all the way over there, so I can't do that without seeing what I'm doing. You can now see that I'm obviously outside of my car, but yeah, without writing any code, just changing the reference space to local instead of to stage, all of a sudden my head starts there, and there you go. Now, at this point in time, you cannot change this in runtime. You can't suddenly say, I want to be standing up and walking around in normal space, and I want to go back to the stage or floor or whatever. You can only set this up at the start, which is why it's a project setting. That might change. We don't even know if that's possible, whether that's in the design. But if you have a game where that is important, it is probably better to keep it on stage and to use center on HMD to switch between the different modes, because then it simply becomes a matter of flipping that keep height. So you say center on HMD, keep tilt, keep height false, boom. Now I'm on the origin point. I can move my origin point in my car. So let's say I switch to my car scene, and that's my vehicle scene, and boom, my origin point is where my head should be, and there you go. There's your camera. Perfect. Camera is in the right place. Or I'm going to go to my environment where in my garage where I'm choosing my cars, and now suddenly I want to be in the stand-up position, and now I call center on HMD, keep tilt, keep height, and all of a sudden I'm my 1.80 m tall person again. So that's a scenario where you might want to use the older logic and let Godot handle everything. And then obviously that means that you do need to go and react on post recenter. But yeah, that's the way of that you need to do. However, for our game here, local is the winner. Now, again, one of the things that that we now have created is that I can actually move away from there. That still is true, right? My starting point is now where I want my head to be, but I can still stand up and walk away if I want, and get into trouble that way. So one thing that we very often do, and for this I am going to go back to my other project, because I think that I have that in here, or did I not build that in here? I did not build that in this, so for that I need to go to my other demo, which is my test XR. I don't always want to build everything from scratch. Oh, by the way, that actually quick tangent, guys. Now that I suddenly realize this, is it in settings? So not OpenXR. No, I don't want to do API. I do need to look into API layers at some point, but not right now. Not that plugin yet. Maybe do have Steam VR. Oh, okay, that's funky. I don't know what that is about, but that doesn't impact us. Controllers. Here we go. So, manage controller bindings. Ooh, our dashboard. Index. No, that's not the binding UI. No, that's not what it is. So, show binding UI. There we go. Oh, here's the show binding UI. So, Steam is not available. Some features maybe. That's fine. I just wanted to show, but you can see that there's, obviously every application where you've got bindings, you can go there. So here we can see that our current binding is our standard defaults for an index grid, and I can create a new binding here. And this bit is I like. This is what I like. This interface is cool. Here I can see my controllers. I can see what everything is. So here's my system button. Here's my trigger, etc., etc. I can go to poses here. Now, again, these are OpenVR poses. These are not OpenXR poses. But you can see that there's a whole bunch of different poses. Now, no. Okay, these used to show where the poses were. So then I don't want to do that. That's a bit of a shame. Because normally you could see what all these. So I think that's our grip pose. No idea what GDC stands for. No, these are our grip poses. No, that's a hand base. I don't even remember what all these are. Left hand tip and right hand tip. Those are what are now our aim poses. Haptics, you can see. Again, it's no longer showing us where the rumblers are. I thought it did. That one I'm not sure if it ever did. But chords, don't even know what chords are. Anyway, my point is that I do really like this interface. So this part I really like, but the whole, different bindings and publish to workshop and God knows what, and I really want to make sure that I don't accidentally create one of these because I kind of like to keep the default and not screw up the way that SteamVR works. And again, because I've already closed Godot, we don't see Godot's stuff. A bit of shame because actually, if I had run that in Godot, we should have seen our our two actions there because I do think there is mappings there. It's just that again, like I said, the interface there was originally made for OpenVR. But anyway, that's the rebinding UI that Steam currently has built in, and part of it I think is absolutely beautiful. But I think the overarching thing, when I, as a user, as an end user, want to do rebindings, I'm inside of my game. I just want to go to the rebinding that I can rebind. This the bindings for the game that I'm in, for the controllers that I'm currently using. I don't want to go through a whole menu system to figure out, because this was still easy. I only saw one. But like in our situation where we have a whole bunch of controllers that we support, and you actually get the whole list shown, it gets confusing really fast. Oh, let go. That's really cool. I like you get a Unity lol. Ronnie, that is fine. There, everybody is welcome here. You need to use the game engine that is the most appropriate for you and the project that you're working on. And there's plenty of people around on, like, even on our Godot Discord, for instance, who are working on their Unity VR project or the normal game project and have been working on that for several years, and they just plan to complete that, but they're checking out Godot. That's great. And hopefully they'll pick something up, and hopefully people who come to my streams and watch my videos pick something up and decide to build something in in Godot. But everybody has their preferences, and in the end, I'm a big believer that game engine choice is incredibly subjective. And we can all like all the game engine. We don't have to make a choice which game engine. I think that's such a stupid thing to say. Like, there's only one game engine that is the best, and I'm going to ignore everything else. It's a dumb attitude. One of the friends that I've made through the OpenXR working group is behind the VR interaction toolkit for Unity, working for Unity. And I love talking to the guy. And I love exchanging ideas. And I go like, hey, cool, man. And I love what they're doing with that. And I'm very enthusiastic and very supportive of their efforts. Because we're all developers working in this beautiful, VR game development world. There's already too much fighting and strife in this world. We should just all enjoy what we're doing and let everybody enjoy the things that they are doing. Except Mac users. Um. Uh, uh-huh. Oh, is that going to go wrong? Can I see it now? I don't know. I can't see on my own camera because it's all lag. But yeah. I'm using my Mac to control my stream. All the streaming is actually going through the PC, but yeah, I'm a Mac user and I'm a PC user, and I do have to admit that in my previous line of work, we were primarily Mac, and I used Macs a lot over the period of 30 years. But ever since I've gone really serious in VR, you know, Mac just doesn't do anything for VR. So yeah, I've been a Windows, almost solely Windows developer for the last 3 years. And the same thing goes there, you know. And I know you were kidding, 6 degrees of crispy bacon. But you know, all these operating systems and all these machines have their place. You know, I've got you know, Apple. You know, there are parts that they are doing very wrong in this whole thing now that they're doing their 50 cents runtime fee, just like Unity tried, and but you know, Apple's got a bigger, strong stranglehold on their users or their developers, so they might probably get away with it. Although I do think that it's more a statement than that they are going to be doing this long term. I think they are mostly just gearing to trying to get the industry to not do what the EU wants to do. I don't know. But I love Macs. I'm still an iPhone user. I love iPhones. But Apple is definitely it's not all good. They do stupid things too. But you know, that goes for everybody. And in the end, it's their business model. It's their business. So okay. Anyway, we have a car. What we haven't tested yet is whether we actually can drive in here. Now, this is going to be fun because I, again, started at the wrong point in time. So I'm probably going to. Oh, this might actually work. Oh, yeah, that actually works. Okay, so my controller. Boom. So this is the thing that I also wanted to test. Is this smooth and proper? That I actually am nicely staying in my car. And there's not some weirdness happening. That's all good. So maybe the reverse needs to be a little bit stronger because that is very slow. And again, you know, I don't care about the clipping right now. Eventually, we need to have a proper model for our car, but I can drive around. And obviously, you know, we need an actual track and stuff to drive around on. But that's not something for tonight, I think. Tonight, I think we have all the ingredients together about how the basics of this needs to work. We can control our car. We have our headset in the right location, so we have our thing, you know, our local stage working properly, which is really, really cool. Which I've been wanting to try out for a long time. So yeah, we have all the basics in place. There. Oh, go there. There we go. Okie dokie. No. Let's actually keep that right. I always want to close that box, but I just need to minimize it. I'm gonna make that twice as much, but that's good enough. Now, the other thing that I find funny is we can obviously run this. Oh, because now, because it hasn't tracked my headset yet, it hasn't figured out where it is. Oh, it's still tracking it based on our original location. So that's interesting to know. Okay, so because I've moved my headset over here, even though I'm restarting my app, it is actually not recentering. So it's only the first time that I run that I get the recenter. If I restart, I need to manually do the recenter. I don't know if that is the same on other devices. That might be a Steam VR thing. That might be different on Meta. You know, obviously, you know, we could run this on. Well, this is the other thing, of course. If we want to run this on the Quest, we do need to have an alternative to this and use our action map input. So we eventually do need to figure out a way to switch between those. But for now, this is good enough. What time are we? We're actually past midnight, so well, it's actually pretty good because I wanted to finish around midnight, and we've actually got all the stuff that I wanted to build in today's stream, and we've covered all the things that I wanted to cover in today's stream. We have our, our base setup of our demo, all done. Because the rest I won't really be able to do until I have some assets. So, I need to start looking at, actually getting a track asset together. And again, for the demos, because of the repo that we're putting this in, we're trying to keep everything as lightweight as possible. So we're not going to put a high poly track in here. I'm also thinking, yeah, I could do the track with CSG polygon like I did for my vehicle demo. And maybe I should. That might actually be a nice idea for the next stream as well. Because we could indeed, with CSG poly, put out a track, and then put in the code that puts, actually, can I quickly fast playing karting Sydney? Hey, let's see if these guys have a photo. I went karting here a couple of weeks ago. Do they have a nice photo of their track? Well, this is kind of, you see a little bit here, but I want a bigger photo of the track. Hello. Come on, guys, you should have a photo of, maybe I just need to go to images. Here we go. So yeah, here we can see the whole track. This is actually probably a good photo. And you can see that obviously that's a whole track that we can just set out with a CSG polygon node. But then we can, see how, and this is for many car tracks where there's just tires all around. And that is what makes up the go-kart track. We could do that procedurally. That would be interesting to make. Now, this many tires, we would probably want to do that in a smarter way. And that would probably be then the only asset that we would create is, instead of a single tire, we would have, like, say, 4 tires next to each other. And then, we put those all around the track. That might be a nice one for next stream, to sort of make that part of this. I'm not sure what is a smart thing there. But I think for the card itself, I'm not a great modeler, and I'm not going to struggle around modeling on stream. I don't think that will be very entertaining unless you guys want to have a real good laugh at my expense, which I'm fine with. I can handle that, but I just don't think that is useful. But I'll probably see if I can get a go-kart together, just in Blender, and yeah, then maybe we do use CSG polygon to put up a very simple track, get some tire assets to put around the track, and that's it. That's the rest is open space. We don't have to do more than that. And then we can race around the racetrack. What would be really cool, I think, is that we stop there for the demo, and then we make a copy of it, and we make a little multiplayer version of this. And, I've been wanting to play around with the multiplayer solution of Godot for a while now. But the issues that a lot of people are currently having who are trying out multiplayer on Godot are issues that are specific to first-person games. So where you're actually controlling the body of a player. When we're looking at this, where we are zipping carts around, it becomes much easier to circumvent the problems. But that said, I think it would be really cool if after we finish the base of this that is good enough for the demo, we make a multiplayer version of it. Yeah, I think that would actually be a really cool idea. That is going to be, I think, the content for the next couple of streams. I am looking forward to building that. Nice and simple little goal. And it will answer a couple of really cool questions and hopefully be very entertaining. And I might actually put the end result on itch.io. And I don't know. We could do a race together on stream. I'll see if I can host it somewhere. Or I might just run the main game here on my computer, and I don't know if my public IP address is reachable. My ISP probably has closed that down, so I probably need to have a look at, hosting it all on as a headless server somewhere, and then everybody can just join a race, and we can have some fun with that, and that is probably also building this into something where you obviously. We have a starting screen where everybody joins the lobby, and where we can select the tracks and everybody can set up their cars. And then we have a start game button, then everybody spawns into the racetrack and we go race. I like that idea. I think that that is I think our next little project, because that is also something that has a clear defined scope. Doesn't have to become the most beautiful game, but it's something where we can say, hey, this is how far we go with it. We have some fun together. Okay, what do you guys think? Do you guys like that idea as the content of the stream for the next couple of weeks to build that and to see if we can make a little multiplayer card game, go-karting game. Okay, I think development wise, that's where I'm going to keep it. My throat is hurting more and more, so I think I have done. Yeah, I'm ready to call it a night. But before I go, as every other stream, I am leaving the floor open for anybody who's still in chat, who has any questions left that they want to ask before we end it. So I'll give it another 10 minutes or so to see if anybody drops in any questions. And well, one thing that we can actually do while we wait for that, let's at least do a very quick implementation of the track. So let's use the polygon. I'm going to call that track. And again, the same thing that we can do here is that we create one. Actually, no, that needs to be, no, we need to go start with a path 3D. There we go. And we're going to call that track. And now we're going to go and save that scene. Track. Yeah, no, you hate that. There are some little niddly thingies in there. We're going to put the polygon there. So, top view. Now, this is the bit that I always find hard, is to really judge scale. So, with this there, 1 meter. So that's going to be 1 meter. So that gives us a little bit of an idea of where we are with this. Which means that we are now going to go and add points. And we obviously want, this is the only thing that I don't like, is I want a point at the beginning, but I can't actually click it there because my widget is in the way. So we're going to put it slightly to the side, but that's okay. We're going to go there. Let's make that our first big turn. We're going to go like this. And we're just going to make a really simple oval one here. Like that. That's going to go there. That. There. And we're just going to close it with the polygon itself. Okay. So this one now needs to do path. We need to assign our track path. So this is the road. Yeah. we need to go and say path joints, so that's completely there. Okay, so the one thing that I forgot to do, which we need to do first, is obviously we don't want to, have 45-degree corners. So here, I think it is this one. No. Oh, no, that's not enough. I want to close it on that because as we get weird issues. It's that one that I was looking for. Okay. So here's where we use our control points. I want to keep that as straight as possible. So this one, there we go. We got our first corner there. Especially this one as well. Yep. Make a nice corner. This one, make a nice corner. And again, this is a boring starting track, but sounds grand. Very cool. Okay, I guess, whoops, other way. This is, of course, a very boring track, but we just need to have a starting test track that we can play around with. And I don't even know if this is going to be the right sort of size, but we'll figure that out soon enough. Okay, now obviously the thing that we now need, so now I'm going to look in 3D. Actually, I probably want to make this a little bit more of a complex track, but first, let's go and make this a bit better. So I want that on 1.5, 0. And I'm actually going to make that 0.1, so that's slightly into the ground. This is going to be minus 1.5 as well, but I actually want that slightly above ground. No, actually I want that 0. We're gonna do a Z offset on this one. Here we're going to 1.5, 0, 1.5 minus 0.1. So, okay, there we go. We now have that. I actually want to go and do my top view again. We're actually going to make this a little bit of a nicer track so that it's not so boring. So let's go and add one more here. We're going to bring to here. And I want to bring one more here. Sure, these can go like this then. There we go. So we have going into a sharper turn. Yeah, that's probably a nice starting thing. We'll probably eventually overlay a Hi Agnes in Coatbridge, Scotland. I 6 degrees of crispy bacon mum. That's cool. No, this is absolutely live. So yeah. So okay, that does that. We now have our track, but the problem that we have with this track is if we go and look over here, that is going to Z fight with the ground. Probably need to save that first before we can see that. Yeah, that does a nice Z fighting with the ground. But what we can do here is we can give that a material. Let's give this a standard material. We don't really care about the type. Obviously, we eventually want to texture this. But what I'm going to be doing, is it actually here? No, actually, it's not on the material. So I'm going to keep that on the default material just for now. I think this is actually on our geometry node. There we go. No, is it? Build range? No. Where are you hiding? Sorting. Yeah, sorting offset. That's what I'm looking for. All right, so let's do. Okay, that's the wrong way. Minus 1 button. Now, does that not do what it's supposed to? I thought that would be added to our Z offset. I guess maybe that wasn't added to 4.1 yet. All right. Well, easy to fix. Let's not worry about this. We're simply going to do is just offset this slightly higher. But now it should be slightly above ground. And yes, as you can see, we're slightly above ground. And that actually means that I actually want the floor. No, I'm going to do it the other way around. I'm going to leave this on 0. But instead, I'm just going to nudge this one down a bit. Transform. It really doesn't need to be much to be on top. So now we've actually lowered the ground. We haven't lowered our collision shape. We've just lowered our ground slightly under that so that we can see our track. And the reason I'm doing it this way, especially because this is a, I might actually go all the way. I'm actually having too much fun with this. The reason why I'm doing it this way, and I do need to do something about the color. Actually, sorry, I'm getting distracted by this, so I just want to. We obviously need to get proper textures for this, but for now, come on. I am going to, and I know that this is being overused at the moment, but I am going to put this in. Oh, let's finish this story. So, on a normal, we'll fix that in a minute, don't worry. On a normal racing game where we would have a road that could bank and stuff like that, obviously we want to introduce a collision shape for our whole track. But in this case, because we're going go-karting, and the go-karting will always be on a flat track, just having a flat, simple collision shape is more than enough. We are going to restrict the cars from not going off of our road by the barriers that we're going to create at the sides. So obviously we're going to visualize the barriers with a tire wall, and maybe a barrier that contains the tire wall. But we're not going to do anything with collision shapes for that. Okay. However, we do need to fix a couple of things here. And the first thing that we're going to do is we're going to use this path simplify. So right now we have got a path interval set to 1 meter. That means that our track is created in 1 meter segments, which actually creates a quite high polygon mesh, which is a waste. Quite simple, simply put. So what we're going to be doing is we are going to use this path simplify where we can set an angle, and I think that angle is in degrees. And what we're basically saying is that if a segment, the angle difference between a segment is less than 10 degrees, we're going to merge it. So we can see that our long straights are now single segments, and our turns are now actually polygons. And I think 10 is maybe a little bit overdone. We do want our nice curves in there. But all of a sudden, our track is a little bit more efficient polygons count. Now, the other thing that we want to do is, and I need to load path by default, the top path with special entire length. No, we just want distance, one single path follow. I think I just want, no, I don't care about that. So we'll keep that on path follow now. Don't care about logo. Let's see if I turn this off. Now it's for every section and not around. Oh, only that one goes from. Where does that go? So I do need to go onto here. Let's say close curve. Okay, now we're talking. Here we go. Okay, I think that we need to do a little bit of the scaling on this is so weird how that is not how I'm remembering that this should be working. But we don't actually need that because that now joins by the closing thing. No, I don't want small faces. Yeah, because this is a problem that we have that. The UV isn't really working the way that I remember it should be working. So I don't know if we changed something or if I'm missing something. Anyway, it is what it is. So let's go and play with this a bit. What does that makes that more? Okay. I remember that 8 was the magic number. But I want to go the other way with this. Nope. Yeah, that looks about right. At least we got some, obviously we need a nice road texture, but for now, that will do. So we have those. All right. So the nice thing about what we're doing here is that we can actually make multiple shapes for the same track. So we can create another CSG polygon here. And let's call that left barrier. There we go. That then needs to be a path, and we simply assign that to the same one. And as we can see, that follows that just the same way as the other. But now we're going to change what we're doing here. Good question. Which way is forward? There, so that way is forward. So that means that way is forward. So left is this way. So 1.5, maybe. 1.5. Then I want this to be 1.6. Oh, that needs to be 1.5 as well. This can be 1.6. Yeah, so that's an inner barrier, but I want to actually move that up a bit. So 0.2, perfect. 0.2, I don't want it to be so high, so this is going to be, let's say, 0.4. Just remember, this is the steel bar that runs along the track that holds the tire stacks in place, because the tire stacks are going to be on the outside. Actually, don't even want that to be this big. I probably want to do that like 5.2, and this one 5.2. And I'm even wondering if we haven't got that too high already. I think I'm going to put that 1, oops, 3, 3, 1. Okay, so we have that. Perfect. So here we actually want to break that up much more. That can be smoother. And actually, I wouldn't mind this as well, seeing that we are optimizing it. Anyways, yeah, we can really see that the UV is struggling here. I don't know why. Something changed in the UV logic. Someone screwed around with that again. So yeah, there we go. This goes a bit better. Because that, or maybe that's just the effect. No, it is actually correct. It is how this is just because of the triangle mesh that is being created that screws it around. And there's possibly a way to to maybe create a center line in here. Okay, we're gonna play around with that in a minute. Oh, hey, Bastian. Just wanted to leave a big thank you for your awesome work. I will soon be working on my master's thesis. Ah, very cool, man. Good luck with your master's thesis. Hope that all goes well. Very cool. And I'm glad that you find stuff that I'm presenting useful. All right, so here we just need to inverse this. So this actually becomes that. Boom. Minus 1.5. Minus 1.5. Did I do that right, like this? Or did I just invert it? No, I think I did it right. Now we have nice barriers on both sides. We'll deal with colors and stuff later. Now I'm thinking that I am going to create collision shapes for the left barrier and the right barrier. So that instead of having collision space on the tires are just going to be for makeup. But I think if we use this as a collision and use this guy as a collision, then we can't leave the track. Okay, before I test that out, I just want to have a quick look here. So I want to add the new one. We're gonna move. Oh, that's very sensitive. There. So that actually is actually perfectly what I want. That's already improving that. Okay. I actually want to go to 7. I'm gonna go 1, 2, which means that I can make this minus 0.75. This one 0.75. And that means that our top surface is now basically 4 individual lanes, and that's just helping with the UV mapping. Now we can see that, you know, while obviously our UVs are stretched on the outer ledge, which is what we expect, and condensed on the inner, but they're nicely spaced for everyone instead of the triangles really distorting them. We don't care about the underside, never going to see that. We only care about the road surface, and that is now much nicer in the way that's done. We nicely have our outer curve working properly. We have now also made that a collision shape. So hopefully, if we test this out, we should be able to drive our car around our track. Okay, are we gonna, there we go. Okay, I do think our track is too small. And I know the go-kart tracks are, oh, boom. Oh, I'm stuck. I just drove into the wall. How about that? Oh, no. There we go. We can still get out. Whee. Wink. Yeah, I am stuck now, though. Oh, there we go. That was funny. Oh, there we go. Whee. Yeah, but ooh, okay, that's getting stuck in the wall is weird. But that probably can be solved by using a better collision shape. However, our track is definitely too small and not wide enough. But that is also the nice thing about this CSG approach, is that's just a matter of tweaking the numbers. And obviously changing the position of our line. So what we can do, let's actually Google it. Width of a go-kart track. And obviously I don't want that in images, I want that in normal. 7 to 9 meters. That is a lot bigger than I thought it would be. So this is only 3 meters. So we need to make it 3 times as wide. So let's start with doing this. So this is in times 3. 4.5. well, here we can see that with that change, obviously our track, but that will adjust our track later. So we're going to go here, 4.5. Here we are going to go, so this is times 3, 1.5, 2.25. It's also 2.25, 4.5. So that is a 9-meter wide track. Good. We're obviously going to make the same changes on the barriers. So that's going to become 4.5, 4.5, 4.52. We do keep the 2 the same because that's just the width of the barrier. Here we go in the other direction, minus 4.5, 4.5, 4.5. Okay. I'm going to hide the road because it's easier to adjust. We're going to have a top view here. Oops. Keep the top view. I wish that I couldn't accidentally change that. That would be nice. Right. So where are our points? So we're going to go and definitely make our track longer. There we go. And actually, the nice thing is we can play around with our track a little bit more. There we go. Put that a little bit more like this. Put that down more like this. We can actually move that a bit more like this. Okay, now we're going into trouble with that one. So here we go. A nice curvy track. Cool. Let's see if that is a bit more drivable. Oh, does help if I keep making my track visible. There we go. All right, let's see if that is a bit better go track wise. Definitely looks nicer. Oh, we can see that our closing gap is a problem. That is always an annoyance and why I actually want to have that close path thing. We'll solve that in a minute. Well, we definitely pretty much going full speed. We need more control over our steering, but well, you know. Wink, wink, wink. But we can at least drive around. Kind of cool. Drive. Oh, bunk. Yeah, I think with just a bit of tweaking of the steering, because the steering is definitely too aggressive, we can definitely make this work. I can definitely, you know, I'm driving at full speed ahead here. So we definitely need to play around with some of the settings and make it a bit more. Well, I guess when we fix the steering, we already get into a situation that if you go full speed ahead like this, you will bump into things. But that's the other thing. Right now, when we bump, we stand immediately still, which is a bit annoying. But yeah, those are things that we need to improve. However, as a first concept, I think that is already kind of cool. Let's go and limit that to 25. See if that makes more sense. Now, obviously, also, you know, I think that I've got the tires too far out at the moment. We definitely need sound in this as well. I need to get some go-kart sounds. Bing. I actually can't wait to hook this up to my my proper steering wheel. I actually have a G29 steering wheel in the cupboard. So maybe for next stream I should hook that up. And we actually make this work with that as well. The thing that we're missing is force feedback. That's something that Godot doesn't support on steering wheels yet. But this is pretty controllable. It's a little bit over easy. The car handles it a little bit too good. But again, it is a go-kart. It's supposed to be very sticky. Yeah, that was actually worthwhile to add in just as a bit of completeness. Are we going to do the tires tonight, or are we going to keep that till next time? You know, we're busy. We're busy with this now anyway. I actually do need to, because if we do tires, that's going to be a problem over there. So we are going to move that like that. This like this. And I'm really surprised that that did not update. Even though those did update. That's really interesting. I did update on here. Oh, we screwed up over there. Okay. Fine. Up you. What I get for trying to do this too quick. Actually want you know what? I am gonna go and delete you. Oh shit. Can I go? Yeah, I can go back. I just wanted to go and do that. I wanted to go and make that a bit more like this. Surprised at how difficult it is to get that sort of bend to work the right way. It's definitely a really sharp corner though. So I might actually want to move this a little bit further out, a little bit more forward. Oh, yeah, that was the other thing that I needed to do. Oh. I actually want to. Why is that doing that? Oh, that's because of that one. Okay, so let's go and move that like this. Here we go. The reason why I'm moving this out a little bit is because I don't want to be on that center point. That does mean that we need to put our starting position of our car differently in a minute. This also means that I need to go and do like that, something. I want to keep that as close as possible. It's the other problem that I can't really control this too much. Obviously, we want to keep that. There we go. And I don't really care about that, but actually what we'll do to make this easier, we grab, oops, that's actually a sorting sort of thing. Let's move that all the way over here. So that, yes, we can make that nice and long, so that we can make this as straight as possible. I'm going to, oh, hey, you are supposed to remove the output as well. Thank you. Yeah, let's go and do this like so. Actually, let's move that a little bit like this. We'll do it like this. The most important thing is that that line is as straight as possible. That's why I'm making this a very long handle, because it makes it nice and easy to do that. So I'm going to put that there. That now means that we can move that closer. And again, so straight as possible. But we're not going to put them on top of each other, because that is what is causing all these problems. We are going to put it as close as possible. Now, what we're now going to do is we're going to join those paths. Now, the problem with the join paths is that the joining bit doesn't adhere to our UV logic. So we get this this breakup in the UV. Now that is very visible when it comes to like a block pattern like this. But once we replace this with a nice row texture, I'm pretty convinced that will be okay. So let's go move that a bit more. Maybe a little bit longer, so that we this a little bit less. Oops. Which means that I can actually move this a little bit more like so. Instead of it, I'm just looking for this not crunching in too much. And I'm actually thinking maybe I'm gonna take that out and instead and click that, moving that a bit more like this. I can then make this a bit more like this, which means that we can move that a little bit in so that we don't get these pinching things as much. I can move that a bit out, that a bit more like this. I'm just trying to get the, I don't mind a few very sharp corners because that's fun, get this high speed corner and all of a sudden you have to slow down and take a left. But yeah. Okay, so the last thing that we want to do is you want to create a multi-mesh instance. And we're going to create a multi-mesh here. Oof. And this multi-mesh is, we're now going to have an instance count of 1. That's fine. Need 3D transforms for this guy. And we are going to do a little cylinder mesh. And let's see, let's just size auto higher actually. Yeah, let's just say 20 inches, yeah, 50. So 0.25, 0.25, whatever. Standard material. You're going to be black, not completely black, but close to black. Not going to be metal, very rough. I'm going to play around with that for the railing later on, but that's going to be our tire model. I am slightly surprised that our tires here, we don't at least have one tire showing up. I had expected at least one tire. Oh, because that is -1 means all. Why can't I change that to 3? What the? What's wrong with you? This is a 3D world. Why can't I change this to 3D? Debugger saying anything? No? Instance count bigger than 0. Size 8. I'm going to leave that to 0 until such time as we actually have data. So, cool. All right. Script track. All right. Nope. You don't. Nope, we don't need you. We're gonna do a bunk. Update tires. All right. Let's always at least update them and position them. That's fine. It's really not that much of a bother. But the other thing that we need is inside. No, that's not the one I'm looking for. No, that wouldn't be that. What is it? I always forget where it is. Okay, let's search for it. Editor hint. Engine. Okay. If engine dot is editor hint, we're going to turn this into a tool script. It's not yet a tool script, but we are going to change that. And here we are going to say node. Oh, yeah, because it's not selected. Curve changed. Connect. Callable. Update. Tires. I think that's what I need. All right. I'm just going to close these things because it works better that way. Well, at least we didn't have any errors, so that's where we're going to start. Oh, interesting. It's a bit of a warp in our barrier. I'm not quite sure what that is about, but I don't really care. Okie doke. I am currently using a valve index, this little guy, which still remains one of my favorite development headsets. Even though it's getting a little dated, but yeah, I'm quite happy with it. All right, so update tires. We now need to update where we position our tires. So for that, the first thing that we need to do is we need to figure out how big our track is. So we're going to say track length is curve dot get bake length. So that gives us our total track length. Now our tire, this is going to be fun because I think the inner tires are going to be, I think we're going to have to, that's a good one. Well, I'm going to do it the dirty way first, and then another day, because I do want to go to bed soon. Then we do the nicer version later, because this is a 1/2 meter through. So basically, we need to place a tire every 1/2 meter, but our curves are going to mean that, yeah, maybe we can put a tire 1/2 meter here, but obviously our inside diameter of our track is going to keep changing based on the curves. So we're going to have tires that are going to be squashed up, and we're going to have tires that are spaced a bit. But that's fine. I'm not worried about that right now. We eventually, what we can do is that we actually go and move along the inner edge, and then separately move along the outer edge and actually place the tires at 1/2 meter intervals. But for now, we're gonna do it dirty. So cheap and dirty approach. Need to improve this. For our tires needed. No. Tires per side is floor track length divided by 0.5. And that means that now, actually, I want my multi-mesh here. For multi-mesh is tire wall dot that we can actually affect that. So now what we can do, we can say multi-mesh dot instance count is tires per side times 2. Because we need a tire on each side of the track. All right. Now we need to place these tires. Now we're going to say for tire in range tires side. That's going to count from 0 to the number of tires for each length. And with that, we are going to place 2 tires at a time. Okay. And now I actually need to go and have a look at this because I also forget what that is. Oh, deprecated. Look at that. So what we're actually going to do is we're going to do a set instance transform to place each tire. That gets an instance ID and that gets a transform. So let's do that one tire at a time. So var t transform. And for that, we then need to go and have a look at shape. No, curve. Curve 3D. There we go. And what we're going to do here is we're going to go and work with our baked points. But we also need to have sample baked with rotation. That's the one that I want. Oh. And that gives an answer. So sample baked with rotation. That's what we want. So is sample, that needs to be on the curve. Sample baked with rotation. Let's just do our offset is 0.0. So this is going to be offset, comma. We're going to leave those default. So we're just going to get that at the offset. Obviously, at the end of this loop, we're going to do increase our offset by 0.5 meter. And I'm actually going to make that a constant. Higher spacing float is 0.5. So that we can easily change that. Boom. I'm actually wondering if we shouldn't make that an export bar. And then that, of course, is not uppercase. Boom, boom, because that way we can have fun with that. Set value. Higher spacing is value. It is inside tree, and we're going to do this regardless of whether we're in the editor or not. But if we do this, we're also going to update our car. All right. That is, of course, transform 3D. We've got that baked with rotation. However, we now need to offset, and actually we need to keep that. Okay, so we're going to start with our left. Left T is T, and then left T dot origin plus is left T dot bases dot x times 4.5. No, a little bit more. 5.0. That is going to move our left underscore T. That is going to move our tire to an offset. Okay. All right, I'm going to do that slightly differently. I know this is going to give me an error right now. Multi-mesh dot set instance transform tire. Now we get the transform, and what I'm going to do is I'm going to actually make that T origin plus T bases. No, that's not going to work. That doesn't work. Okay, I do need to make a copy. That sucks. Yes, what I'm going to do here is going to say var T adjusted is T transform because I actually don't want to. What is that plus is? No, that. Okay. Cool. Again, I make the same mistake as before. Oops. All right. Okay. So let's close that. Reopen it. Ooh. All right, we have a lot of tires, but okay, 888. I can believe that that's how much we would have. Okay. Now I'm placing them every 10 meters. Seems to be doing that properly. Every meter. So why did it completely screw up so much just now? I don't know. I think the tires are actually too small. And we actually need, obviously we need a tire model for this. Let's go back to 0.5. Why is that going so weird? We must be getting on some weird minimum or something. Anyway, oh, actually, is this on the left side of the track? It is actually on the left side of the track. How cool is that? So now we are also going to add the right side of the track to it. Boom. So again, just put it back to T. But now we're going to subtract it. That means we're going to do this. Okay. Oh, it's already done. There we go. Sweet. I think that this guy probably be a bit bigger. And oh, it can also be, because that's the other thing. I need to actually make this a bit up. That's why it looked weird. So they're through the ground right now. There we go. Oh, because it's the height. Okay, so this is actually now the tires get a bit too big. Let's make that 3.5, which means that I should actually make this 17. That's good enough for now. Obviously, they're cylinders instead of, well, they should be donuts. Hey, Nub, how you going? I am making a demo for our demo projects where we are driving a little go-kart around the track, but in VR. Oh yeah, my starting position is wrong. I forgot to change that because I made my track positions different. I need to go back in main. I need to go to my vehicle and I need to now move that onto the middle of the track. There we go. So I'm in VR. I've got a little track that's nicely created. I've got a stupid little box to drive in. And here I go. I can drive around. So we can see that indeed the tires are squished together on the sharp turns. So we definitely need a better algorithm for that, but that's fine for now. I don't care. What I care about is that in principle, everything works. Whee, whee. Oh, and I crashed into the wall. Come on, I'm stuck on the wall again. Why am I stuck on the wall? I'm not that close to it. Come on. Come on, get out of here. Okay. Long live Godot physics. Why can I not exit all? I think actually it's because I'm moving. And because I'm moving, I'm actually not getting to my minimum velocity for going in reverse. So, cons min velocity float. Let's actually keep that at 1 meter per second. Oh, equals. Let's see if that still works or if I've made my life difficult now. It's working. Cool. Break, reverse, break, go forward. Whee! Yeah, definitely needs sound. Okay, I'm stuck in the wall again. But yeah, that was the problem. My minimum velocity. It's not working. I do think it's weird that we can get stuck in the wall that way, but oh well. That is something that is just fine-tuning the shape. So we have a box as a collision shape. That's really not very conducive. I keep running into that side, don't I? Still got the steering to... I wonder if we can actually make it so that if we go that fast and we steering that strongly, that we actually have the back slide out. That would be actually really cool. I am just constantly making the same mistake. However, sweet. So yeah. Yeah, I am really having difficulty with that corner. However, we got something. All right, Stefan, I made a Blender file where you can make tracks with curves, which will automatically enhance party in the mesh with textures. And then we export GeoTIFF. Yeah. My OBS says that it's disconnected. That's not good. And I'm reconnected. So am I back? Let's see. I might have dropped out for a second, guys. I think I got disconnected for a second there. So sorry about that. All right, we're back by the looks of things. So yeah, little technical hiccup there. I don't know what happened. However, so indeed, Stefan, I'm doing this in Godot right now because, well, first of all, because with projects like these, if I want to submit them to the demo project repository, it is better to generate as much as possible in Godot. I do like the using the path or the path and CSG polygons to quickly put something like this together into prototype. But definitely Blender has so many more better tools. It often makes far more sense to do this stuff in Blender. So yeah, also been a small game where you can ride a pedal car in. That is cool. Yeah. I don't know if you're around on the Godot Discord, but if you are, do post a video. That sounds amazing. All right, that's my last bit of water. So anyway, for the people who only just joined in, I am very sorry. I am about to put an end to the stream. It is past 1 a.m. for me. I am beat. But just to repeat what the plans are here. Like I said, the goal initially is for this to become part of the XR Godot demo project. So these are small projects in the official Godot demo repository on Godot engine that show, basic XR mechanisms. And the whole idea here is to keep these small and keep these very much to the point. And then just like for the other two, well, in the other two, I did the other way around. I started with, the documentation, and then I added the two demos. Here, I'm going to do it the other way around. I am going to finish this demo, and and then write a small bit of documentation about how it works. Now the highlight, which I'm really happy that works exactly as advertised, is setting the reference space to local. I think that's going to make life a lot easier for a lot of people, which is really cool. But this is also where the fact that the OpenXR action map is separate from normal controller inputs does get in the way somewhat. So I think next stream, whether that's next week or in 2 weeks, it probably is in 2 weeks. You know, I at least hope that that I'll have some at least a nice asset for the go-kart. And we'll just spend some more time just polishing this up and making sure that this demo contains everything that it needs to. And then we'll upload it to the demo repository. But the idea after that is to then make a copy of this project and dress it up a little more and see if we can make it into a little multiplayer racing game. That does sound like a neat thing that we could get to work. And just have some fun with that and see what we can do. And then, you know, maybe even go to an approach where we have more than one track. And I think that's a nice little, you know, little small project to do on stream and just improve on stuff. So that's the plan. We'll see if we can stick to it. But it's, yeah, looking good so far. It's a nice little thingy. So, with that, I'll give it another 2 or 3 minutes in case anybody has questions or any last remarks to make. Else, we're going to call it here. I'm already almost 1.5 hours over time. Luckily, I don't think I've got anything in the morning for which I need to be awake early. So I can sleep in. That's a good thing. But yeah, this was cool. This was successful. I'm happy with what we achieved tonight. This worked really, really well. So yeah, I hope everybody enjoyed themselves and found this interesting and found this useful. Nicholas, thank you. Yeah. Thanks for the support. That's really nice. So yeah. So let's see. You mentioned that it was 5 a.m. at the beginning of the stream. So where are you now? You're well into your day. You're like around 10 a.m. No, 9 a.m. then probably. Very good. So yeah, thanks everybody. Thanks for yeah. I'm glad you guys enjoyed it. This was a bit of a gamble of, you know, I'm doing something completely new and out of the blue. But I'm glad people find it useful and found it interesting. So cool. All right, cool. Well, that's where I'm really going to call it. So everybody have a great day. Have a great night, whatever time it is over at your end of the world. And again, thanks everybody for tuning in. Yeah, I'm gonna, like I said, I'm gonna try and keep to at least a stream every 2 weeks. If I can do one in between, I will. But the schedule at this point is to try and do a stream every 2 weeks and try and do that for, you know, a longer period of time, and we will see where we end. So yeah, that's where we leave it. Good night, everybody. Thanks for stopping by. Like the stream if you liked it. Leave comments if you want. Subscribe if you haven't already. All that YouTube jazz. Everything helps in supporting this this channel. So everything, you know, in that sort of thing is appreciated. We'll leave it there. Good night, everybody.